We are live. Welcome. Yeah, so I'm making this game and also tools to make the game in Zig and Raylib and a couple of other things. So I actually thought now I've been doing some stuff off stream, but right now I'm thinking I want to work a little bit on the editor, since I want, well, the next phase that I'm sort of working on in the game is making the maps and stuff, and so I thought also, and also the some animations and stuff. So I thought that the animation tool needs a little bit of upgrade, and what I was thinking is moving finally the animation tool or the animation editor to the game editor that I'm building, so that all editors are in the same sort of space, same place, in the same program. Yeah, what we're looking at right here is a string struct that I'm building here to more easily sort of handle strings in this amalgam of program that I have with imgui, which is, I'm not sure how to pronounce it, but it's like a UI library for C, and it has a SIG port, and or not a port but bindings, and it also has an integration library with Raylib as well. So I'm using that as a UI, sort of easy to construct a UI, which works pretty well, I would say. And yeah, so I'm building a string struct here for just having strings that you can have as both edited easily from imgui, as well as can be saved easily with the with serialization. Hey yo. Keep them Super Metroid gameplay coming. Yeah. Nice. I actually replayed Super Metroid not too long ago, and I was welcome, by the way. I was actually, I didn't remember this, but I was surprised at how good they actually made the level progression, like the progression in the game. Like, it's like interweaving between these different areas in such a nice way. So I was very much inspired. Yeah, I love Metroidvanias. I hear that you also do that. That's nice. So yeah, but this this struct will help me build these new document types for the editor. So yeah, so I'm gonna use this because this was a pattern that I noticed, so I have now moved this to a separate struct here. So let's try to use it. And I'm in the process also of putting this animation here, the animation document, so that we can start building the animation editor here. And let's see. Yeah, so we've got our frame struct, which is just some ordinary data here. We have the animation with a name, and this, when it comes to strings, it becomes a little bit cumbersome sometimes to deal with, especially if you want to integrate with C libraries and stuff. You always have to have this zero terminator, and yeah. So what I'll do is I will say we will have this string Z thing, and just implement that, and then we can use it like this. So you put in the capacity of the string, so let's say 32. So that's the maximum amount of characters for the string. And let's see. Yeah. Let's see. So that should be good. And then here we have to say string z32.init. And here we can say an initial slice, which is the same thing we're putting in down here. So now we don't need to do this thing anymore, which means we can actually just return this as well. Okay, so we have this new animation, and we put in the allocator as well. And what this does, it's gonna basically do the same thing here. We're gonna duplicate this initial slice. Oh yeah, you use dup z, which actually appends a null terminated element, so that's perfect. So we don't really need to use the buff print thing that I used. You can, if you just have a string that you want to copy over and make it zero terminated, you can use dup z. Okay. And then we have this get buffer, which is used for the imgreave library, so that it knows what the capacity is, because you have to provide a slice that has a certain length, so it will use the length of the slice to know what the capacity is. So you have to like convert it into like this. You cannot say this has this capacity. You have to like yeah, you have to pass in a slice like this. And then we have a set method as well that will yeah, just set the new name. Also, I forgot here, we actually need to provide an allocator, because we need to free the old value as well. So we need to free this one. Okay. Actually, I wonder if you have to free the pointer. Let's see, because the slice, the length is, let's see, this takes the type info. If it's a pointer, which it is, I believe, when it's a slice, it's a pointer with type slice or something like that. And let's see, size, I believe, yeah, size is, yeah, slice. So, but it doesn't check for the length. Oh, slice as bytes. So it does this. Right. So I think it's probably safer to provide the point. Well, actually, let's just do get buffer here. So then Yeah, that because then you would get the correct length that it has to free here. Okay. Yeah. So set will take care of the previous value. It will also set the new one, which again, here we're using buff print z, but we can use dupe z also. Actually, you know what? Well, we need a deinitialize also, so let's take care of that. No, this won't return anything. And we will just, well, we need a allocator. So allocator free self get buffer. Why am I not in? Oh yeah, because we need to do capacity like this. You can use, you can, instead of typing out all the like strings and capacity, you can use this, so you don't have to provide the type. And a pattern that I've seen in the standard libraries, you can do this. So then instead of typing this out all the time, you can use self like this. And that's a way to alias the type. And yeah, also here and here as well. So then if you add more configuration stuff here, you don't have to change everywhere where the type is used. Okay. So now we have deinitialize as well, so we can call that to deinitialize the buffer. I guess we could call deinitialize here. To do the same thing. Let's see, I'm just thinking here, like, yeah, this should be exactly the same as doing allocator dupe z, because we're getting a new buffer or a new slice out, but it's printing no, because this, oh, okay, it's not the same. I was lying. This is actually printing to a destination. It's not creating a new pointer, a new location. So what's actually happening, oh yeah, so I have to rethink this a little bit. I think what we're doing is first we want to create this. Okay, yeah, I did not think this through actually. So what we could do is this. We could have a thing here, and we can say we can add a new block thing here. And in my experience, every time I've done this, I've moved this to a separate function. So I'll just do that. So this would be init slice, let's say, and we will get this out, and we will provide an allocator and initial, let's say value here. Okay, so this will basically be the same thing. Also, I need to, this is a pattern to have the allocator first, so I just move them around. Okay, so instead of doing this, we can do init slice with allocator and initial slice. Okay, so what we're gonna do here is we're gonna first create the buffer, and think it's alloc with u8, and actually it's alloc set maybe. No, with sentinel, alloc sentinel. So this one takes the element type, which is u8 for strings, the capacity n, and also the sentinel at the end. So the sentinel will be 0. Let's see, n will be capacity that we have from the type, and then the sentinel is 0 for 0 terminated string. And now we have this function, and we can, yeah, so now we're using that here. So we're initializing the slice like this. Oh yeah, and we also need to return this and cache unreachable. Right. So the type now says here, the LSP says it's just a slice of U8. It doesn't know. I've been through this many times. It doesn't. I'm just checking what the type is, because this returns. You know, you can see the sentinel type here. So it returns the sentinel type, but then the LSP doesn't recognize that it's sentinel. It just says it's a slicer, but it works. The compiler doesn't complain. Actually, we could just no way. So we want to return it, but we also want to say we also want to populate it. So what you do is you use buff_print_sed. Well, it's part of the format library. So buff_print_sed, the buffer is this guy, and the format is this, and the arguments is value. Okay, so I kind of when I talked about dupsed before, I actually totally forgot that the original slice or the original buffer here is only allocated once, and then when you wanna, so in the initialize, we initialize it with the capacity, and we print whatever initial value we want to have onto that buffer. Then if we want to set the thing, we actually don't want to deinitialize, because we want to keep the same sort of location, but we can just print something over it using buff_print_sed here. And actually, you know what? In its slice, this should actually return this one. Yeah, because slice should point. This one should be a slice which points to this, to the buffer, but the length should be whatever length the string actually is. So the underlying pointer has larger capacity, but the slice itself has the length that the actual string has. So let's say you're just putting in 3 letters, 3 characters, then this slice would have 3 length, but the underlying pointer will have larger capacity, would have this capacity. So for name here, it has 32 capacity. Whoa, what's this? Huh? Okay. So let's just go through this again. So we have the slice, in its slice, which creates the buffer for the capacity that we need. It prints over the value to that buffer with 0 terminated sentinel there. And we have the deinitialize, which frees the underlying pointer. That should be good. This one returns the underlying pointer here by taking the pointer from the slice and making a new slice that is has the full capacity, and then we pointer cast that to a 0 terminated sentinel, because when you do this, it doesn't have 0 terminated. It's the wrong type, but we know that it's 0 terminated, so we can just use pointer cast there. basically so the C compiler doesn't complain there. Let's see, and then we have set, which basically just sets this to buff_print_z. So buff_print_z doesn't create a new location. It uses the same pointer, underlying pointer, and it prints the new value onto that with 0 terminated. So that should be good. So now we have this basic string struct, which works better with in green. Okay, so we initialize this. We need to flip these around. Okay, so now we can use that to do this. And we don't need to have get name buffer. So before I had this for each string separately. I guess we could keep set name here. But what we'll do is we'll just say name set, and do we have an allocator? No. So we need allocator. Actually, do we actually need an allocator here? No, we don't. Okay, so let's remove that. Okay, so we don't need the allocator. This is just new name. So we'll just keep this for convenience here. All right. Maybe we don't really need this for convenience though. Let's just remove it and okay. Now most of this code I have not yet. I've copied over this code from the old project, so I have to go through it and see if I need to change stuff here. So okay. Let's see. So we have add frame. That should be the same thing. Select frame. So I'm thinking of making this select frame into not putting like the frame itself as the selected frame. Instead, I'm thinking about making it the index instead. But let's not do that right now. We have remove frame. We have select frame here. So we don't really have these inputs anymore. So we can remove those. The thing about this is like, it was kind of nice. How I did this before was I had this float inputs, or this sort of input structs, which for numbers, for example, you could define a, let's see if we can go back here and see. You define whatever this is, max digits. So that sort of determines the length of the input, and also the max decimals if you wanted to have like a actual integer, but you want to use F32 as a type. You can do that. So for grid size X, you would have up to in the hundreds, because you have 3 max digits, and then also max decimals is 0, so it's actually an integer. And then the code that is responsible for rendering the UI will take this float input, and it will do whatever is according to this input thing. So that was kind of nice, and you also have these convenience functions that you can use there as well. So I'm thinking about also moving them over, because I don't really have the same kind of thing in the new thing. But I will for now not use these and just use the source values directly instead. Selected frame, sure. Okay. Let's see. yeah, we have the serialized version of the animation here as well. So I don't think we really need this anymore, because this struct, this entire struct is supposed to be serialized anyway. Also, yeah, we don't actually have selected frame. Yeah, so all UI stuff, all UI state stuff is not actually in here. This is supposed to be only the serialized thing. So actually, we can remove these things. So we have to do those in another place. Okay, we could keep those things there though. Let's see, so we don't have serialized, we don't have deserialized. Okay, because it's supposed to be just this dumb sort of component or struct that has serializable things in it. And string set should be also like serializable. I wish there was a way to sort of alias this and not have this as a separate struct and just have it as a slice directly, and you can have these methods on it, operating on it. Because that way you won't get a, when you serialize it, you won't get like a name and then a slice on the name. The name will actually be a string itself. However, that would require that when you deserialize, you have to know that that's gonna happen. You can implement like a JSON, like custom JSON serialize and deserialize here for that though. So you could do that. I mean, I guess it's pretty easy actually. So what you do is you have JSON parse, JSON stringify, and JSON parse. Let's see, do I have that somewhere in this thing? Yes. So here's an example of a really simple one. This one only has this, which is basically a U128. And we implement these two methods for it. So stringify, you take a JSON writer object or struct here, and then you just take write, and it will write out the this will become a string, basically, the serialized. So it writes out a string. So this struct will serialize into a string and not an object with UUID with that then is a U128. It will serialize into a string, and then when we parse it, we parse out a string because we know it's that's how the serialized version is. And then we create the struct from the string. So we can do the same thing here. So I'll just paste that in. And this one is going to be self. And then we basically just provide a slice here. Yeah, and we know the capacity because that's hard coded into sort of the type, so that's not gonna be an issue. Also, this one should also be there, and here as the same thing we parse a string, and this is the type that we parse from the other one, which is a fixed length array here, but we actually want to just parse this. Okay. And then we do string z. Well, this is gonna be self. I wonder if we should use init. Yeah, we can just use init allocator and then the string as the initial slice there. So that's very easy to do. So now when it's JSON serialized, it will serialize into a string instead of an object with a string in it, and then back from a string to this sort of string object. So yeah, Pretty simple, actually. Well, you just need to know how to do it, and there is. I'm not sure if there's documentation on this. I think I found this by example, but yeah, it works. It should work anyway. Okay, so now when this is serialized, name will actually become a string. Yeah, so that's good. And let's see, we don't really need to specify this as undefined, so let's remove that. Okay, I think that's it for this struct. I just need to, let's see, we don't use this, and we do use the other stuff. Okay, so now let's go back. So I was in the process of adding this new document type, so that there's kind of the sort of initial, like a foundation for making the new editor is this document, which is meant to be sort of, you open the document and it's an animation, so it's gonna be opened in the animation editor is the idea here. And yeah, and then I've also made like a template for the documents now. So if you want to make a new document, you basically just paste that template in. So it's a bit faster to do because I'm gonna have a bunch of different types of documents, so that's nice. Let's see. Yeah, and we'll put editor state here. So here is where, you know, sort of the input stuff will happen, will go, and selected frame and stuff like that, selected animation. So it might be, yeah, I think when I select animation, I'm gonna have the animation be, I'm gonna have the UI state basically reset for the animation. So the selected frame will basically be, because you're gonna have a bunch of different animations, so you're switching between animations, then the selected frame will basically just be reset. And that means that I can just put selected animation here. Let's just use index for now, and we might not have one, and let's initialize that to null. And then also selected frame, I'm also gonna use index here because it's easier to think about right now. So I'm gonna use that, and yeah, so let's see. Let's also move this. I prefer, actually, the more I've done this, the more I prefer to have the defaults written here, because that saves lines. And it's easy enough to check what the defaults are, so don't have to specify everything in it there. Okay. Let's remove this. So yeah, we actually need to load in textures and stuff as well for this, I just realized. But let's one step at a time. So I'm just gonna check everything here first. So, and here we have serialized and deserialized, which is very simple. We simply take the animation part. So if I just go through this animation document here. So this animation document is meant to be a editor state plus the animation data itself that's going to be stored in the file. So this animation data is meant to be a serializable object that is stored as the file, and that's all the data that's needed for the animation. But for the UI stuff, the UI state, we have to have more stuff. So we have to have selected animation, selected frame, all that's stored in here. We also have this arena, which is meant to be, this is like what you use to store the animation in the memory, and then you can easily deinitialize everything in the animation with this arena as well. So when you wanna, and that's because we read it in as a JSON object, so it's more easy to do it like this. You could also use what's it called? The well, what we do is when we deserialize, that's when we sort of load in from a file. We use this method so to deserialize the string into the animation document, and we use the JSON library to get a parsed object with parse from token source, and this parsed struct holds the value, and it also allocates everything with its arena. So it has an arena allocator that you can call deinitialize on, or you actually call deinitialize on parsed itself, which will call arena deinitialize. So that will take care of all the allocations that was made to actually create this thing. However, I've ran into some problems with using the parsed thing directly, so and like making changes to it and stuff. So what I do is I basically clone the value inside parsed. So I actually implement a clone function for each of the serializable stuff. So it basically just clones everything, and everything that requires reallocations and stuff, I actually have to clone that as well. And so we're doing that because we get a new location that is, or wait, this, well, yeah, this, wait, 1 second, I thought this was supposed to be a pointer. Well, actually, okay, maybe it doesn't need to be a pointer. Well, anyway, we're making like a new thing, and all the point is that all pointers inside this will get new locations and will be allocated to new places. So you will get a copy that has everything in separate locations. So it's safe to put into this new location here. Now we create the animation document with a new pointer here, and we initialize it. We set the animation data to the cloned data, and then we call this load function, which for now, oh, well, this is not good. We don't want to do this. The point of the load function is to basically initialize any like resources that you need to, like the textures for the animation and stuff. We don't actually want to do this. We have to do this, yeah. This should be what we need to do. Also, selected, we don't actually have selected in here. I'm not sure why I put that in here. Selected is not a thing that we need to do in the data part. Okay. There we go. Where were we? So, let's see. Document. Okay. So, yeah, okay, so we need to initialize it here. Yeah, we need to initialize it here, and then in load we load all whatever we need for the textures and stuff. Okay. We don't have an unload function because, yeah, it's not necessary right now anyway. You might need it if we're gonna open like a lot of different documents and you want to clear out some memory, but it's not really needed right now, so I don't care to implement it. Why am I not getting this type here? Also, it's interesting that I use try here. This should really be like catch and reachable. because we do that for everything else. It's just this one that has like an error. It might get a parse error, and but all like memory related stuff, like if you're out of memory, I just catch unreachable that, because yeah, it's not going to be an issue. If it's an issue, it's like, oh yeah, this needs to be that, not self.allocator, and we'll do this. We're gonna populate this with something later. I just want to make this sort of work as in a skeleton, and then I'll add more stuff to it. Okay. Wait. Oh, why did this change? Oh, there's something wrong with the rename function. It messed up some stuff that it shouldn't have, I don't think. Because I didn't rename this, I renamed something else, but it was also called scene document, and it was, yeah, so that, wait. One second. Alright, I'm back. Oh yeah, so we have these vectors as well. These, I think, well, these does not really need to be. Yeah, the issue here is I've copied over this struct from the old project, and these vectors originally was floating vectors, so, or yeah, vectors that had floating numbers, but now I'm using the vector type is actually a integer. Let's get lib in here. I should probably add this to lib. Also, I'm trying out this pattern. I basically have a lib file in, so the, okay, I should start from the beginning. The problem you run into oftentimes is that you want to import something, and it has to be like relative to the location where you are, unless you have a separate library that you have like put in the build system, and you have like a module that you actually can import, and you do that. You can do that as well. This, however, is a more maybe lightweight way of doing it, I guess. I don't know, but you can use this to create a library file in your root source directory, and you then import all of the things that you need to import everywhere. So I have basically all things that I need to have shared in here. And also I realized I need to add animation here as well. So then, because it's in the root directory, when we want to use it, we can actually import lib like this. And this is always going to be the same. It's not a relative path. So you can specify root, which will automatically target the main.sig file, which, if we go to main, I actually export a lib constant that is importing lib. I also have this config as well, so that you can use that as well, which is just a bunch of constants. But then you can use this lib like this, so you can import root, which is main.sig, and then .lib, so you will get access to all of the lib stuff. So you can now easily import everything that you want to have in your project. And as I said, you can create a separate project and include that in the build system as well, so that you can do like a named module import of that as well. But if you don't want to do that, you can do this to keep everything in sort of one place, and you don't have to change depending on which relative. If you're deep in a directory somewhere, you don't have to specify the relative path to the file. You just import root.lib. So that actually is kind of nice. Okay, especially for like the auto completion. That is, like you say, I want to import this, and you get this, so you don't have to worry about the path there. Okay. So anyway, now we have string z in there as well. Okay, so now that these vectors are actually, you can see there, they are integer vectors. So let's just do that until we run into some issues. This is also like grid size makes sense. It's gonna be pixels, so it makes sense that it's gonna be an integer as well. Now let's see, frame duration is f32, and yeah, so everything here, it just should make sense. Okay, let's go back to the animation document, see if there's anything else we are missing here. Yeah, not for now. So what I will need to do now is add an animation editor. And where we do that is we have this big sort of context, which, this context struct, which basically is the entire editor state. Well, for all different types of editors right now. I'm not sure how I want to have it later, but it's just convenient to have everything in one place. So I think, yeah, that makes sense to me. And so it has all these different things. And the thing that we have right now is each document, each editor only can have one document open at one time. And we have time map editor, which has the time map document. We have the scene editor, which has the scene document. So I'm just going to continue on this path until we reach the point where, okay, now we can have, you know, several different things open and whatever. But I'm just going to continue with this for now. So we're going to have the animation document. And yeah, we'll start there. And we'll go up here where we import these things. Oh yeah, so now we can actually, here I'm noticing that we're not using lib for some reason. Here we can actually do lib dot I think documents, yeah, and then scene document. So now we can use this instead of doing this whole thing. Scene entity. Okay, so this is interesting. We have, but we should, yeah, since we're using namespace here, we should actually be able to import this by the same thing. So documents, but it's kind of weird that documents has scene entity, but yeah, whatever. It should probably be something else organized here. Yeah, but now we can do this. Okay, cool. And yeah, so now we have the animation document. Let's go here and see what we need to populate this with here. So we have scene document. Yeah, so this is, so yeah, we have these specific functions for each type of document. And as I'm doing this, I realize that maybe it's better if we store all of those in a separate thing so that we can easily copy it and make some changes for the new thing. So we can even maybe generalize it. We will see. But you can see here we have for time map, we have, well, this is the initialize for everything. Yeah, we also have the file name stuff, so let's add this as well. We might actually create an separate struct for these things, like an editor struct. Editor. Let's actually do that. That sounds like a good idea. So we'll have all of these things. We'll have a current file name. Not sure if n should be small here. I always put name as like a separate word for file name. So let's just copy this pattern. What else do we have? We have the document and initialized. So let's have document. Actually, this could be we can actually make this generic and say we'll take a document type, and this returns a type. And 1 second here. So just making some sandwiches here. Let's see. All right. Let's also do self equals this. Okay. And we make an init function times self. All right. And document. Okay, let's see what else we need to actually put in there. So these things should be, this is actually specific for the time map editor, but I'll just ignore that for now. Specific things is gonna be separate, but we have the editor, And we might put another type in here, which is like the specific things for the editor, maybe. I'm not sure actually how we want to organize this, but that's one way of doing it. Another way would be to have a separate state that we have to take care of from the context. So the editor takes care of like this generic stuff, and then the context takes care of the specific things. We'll see. Let's see. Yeah, so we have the document. The actions are actually also specific to the time map editor right now. This is also that. The project, we don't really have this is not really implemented yet. But we'll get more relevant as we implement the asset manager, which I'm thinking about doing next as well. The input time map size. Yeah, so that's the time map size. We have some textures. Oh yeah, because these are... Wait, exit image. Oh yeah. So these are not textures that we load in from a file, they are textures that we generate from some color. And here's which editor that we have open, basically. So we can add animation here now as well. And play state is when you wanna run the game. Alright, I think that's it for the data. Let's see whatever things we have here. So here we have a bunch of stuff that is specific to the different editors. So let's copy that and put it here. And we'll rename this create file data, create default file data, free file data. Okay, so I think I will rename these to like document, create document data, and oops. This is gonna be self. I don't think we need this to be a pointer right here. Well, no. And let's do, this would be document arena. Do we have that? Oh yeah, because, okay. Actually, yeah, okay. This is gonna be, so I don't think we really need this though, right? Let me check here. We have time map document. Okay, 1 second. I just need to make some sandwiches here. I'll be right back. Alright, I'm back. One second. Okay, so where were we now? Yeah. So the thing is here, if we go, yeah. The thing is, the time map document, we actually use a special allocator for this, and I'm not sure if this is a good idea. If we go to the scene document, we actually have the arena here, which to me makes more sense than to have it outside. And we use it, we actually don't use it, interesting. Wait, this has to be used somewhere, right? No? Oh, we don't use it. That's interesting. How do we initialize? Let's see. Right, so we're using the allocator there. So we don't actually use the arena allocator here, which is interesting. I guess we don't really need it. Okay, let's because 1 second. Okay. Yeah, I don't. Maybe we don't need this. Because the thing with the time map is we're using an. Oh. We're doing this. Maybe we should do the same thing for that as well. Then we don't really need to use the time map allocator, like a separate allocator for it. I think that's why. I think, yeah, when we deserialize, we set. Oh yeah, we're using an arena allocator for this, right? But I don't think we actually need to do that now with this new pattern. So what we'll do is we will copy this pattern. This is basically gonna be the same for everything. And well, it depends on clone. This one is also, we don't need this to be a pointer either. So this is the old thing. Oh yeah, it's leaky, that's why. So we parse it as leaky and then we store it in our own sort of arena allocator. But if we do it like this, we don't really need that. We can just use a normal allocator. and then this is the data, and this is the document, and this is let's see, what do we need? Time up history. So time map is gonna be parsed. No, it's gonna be data. No, actually, this is just gonna be it's just gonna be this data. Yeah. But we don't have a clone function, so we have to implement the clone function. Wait, what am I doing? No, this is undefined. And what did we have? History. Oh yeah, so we can just say history in it. I just don't like having this as separate places. Like, yeah, there's almost the same thing in separate places, because once you add a new thing, then, well, actually this is gonna complain in that case, so I guess that's fine. Okay. Let's see. Yeah, so that creates that, and then we set the data here. So but this is called time map. Why is this like? Let's do the same thing here, and also oh yeah, this is time map. There we go. All right. Data, yeah, because we don't have the clone function, so we have to implement that. Oops. Clone. And clone, and we'll get one out. Okay. So we'll just copy that, and then we need to set each thing to whatever. The history has a bunch of actions. I guess we could add a clone to this as well. Oh, we already have. Wait, no. Here. Let's add a clone function here as well. Clone is self. So what this does is basically it's copying all of the values into a new onto the stack here with this local variable. And then you can return that, so you get basically a copy. I mean, it's not doing anything basically right now. We're just copying the values, but all the pointers is gonna have new locations. So what we need to do is this was just a U size, so we don't need to do anything. This, however, is an array list, so we actually need to create a new array list. I think, is there a, yeah, you can do clone, but what we need to do is actually check this creates a copy. However, we need to also clone check if we need to clone the actions themselves. I think these are just, well, there's a lot of things in here. I mean, yeah, if we just do this, for example, I think, yeah, this has snapshots, time maps. Yeah, this is a lot of things that we need to do. In order for this to work. I don't think this one has a clone. Yes, it does have a clone. Okay. So we already have clone for time map. though. Okay. So so we might. Oh, we already have clone here as well. Wait. Oh, this is snapshot again. But I think this is very easy implemented. We have clone and doesn't need to be pointer. We do need allocator. And this one returns self. And we just return snapshot before equal to self snapshot before clone. Is this always populated? Yes. Snapshot after is equal snapshot after. There's also a point here where snapshot after is actually not initialized, but I think that's just when you are in the middle of doing an action. So it shouldn't be a problem because clone is basically only called when we load things in from a file, and in that case it should already be done. So let's see now. Wait, history, yeah, history clone. The actions themselves need to be cloned, so it's not enough to clone it like this. We actually need to do array list and then action and then initialize with capacity. We need an allocator and we also need to specify. So, but we can do actions.length or items.length. Catch unreachable. So now we have this capacity. So now we have an empty sort of list with the same capacity. We also need the allocator. Okay, and then we just need to, well, we'll go through self actions items action, and we'll just append this, and we can assume capacity here, so it goes a little bit faster. I guess it's not really that important right now, but because we know that we have a capacity, because we are initializing with capacity, so we can just assume capacity here. And now we can say action.clone or not. Isn't this? Oh, maybe it didn't have that. Also, I'm curious if this. So assume capacity actually doesn't have an error, so we don't need to catch unreachable there. So that's nice. Let's go to action and implement the clone function though. So this is going to be pretty simple. We're going to do an inline switch on self, like we do in the other places, and we can just do clone like this with the allocator. Okay, and that will, yeah, take all the different types, all the different tags, and produce the same code for it. It will call clone on the specific type that you have. Okay. And then, yeah, so now this one works, and we need to pass in allocator. Okay, so now we have this clone function. There was nothing else that we need to clone. We have next action index, but that's just a use size, so that's going to be copied in this port. Okay. Now we have history clone, so let's go back to time document and this clone. So history is equal to self.clone. Right, so now we can simply do this. And then we also have a time map, which already has, wait, not self.clone, self.history.clone. Time map also has a clone function, so we can simply use that as well. And there we go. We are producing a new time map document. So now we can, yeah, where now this is implemented. So now this whole thing should be good, right? I mean, here we can just set this to data directly. We don't need to do that. Also, the history. Wait. What? No, the history is. Wait, we're reading a document. We shouldn't read it. Or. Wait. Oh. Right. Okay. I see the issue here. So the pattern that I decided on scene is actually we only store, right, we only store this, the scene object, not the scene document object. And when we load it in, we actually, but the issue here is that we have a history that we want to save as well for the time map. So the time document has the history, but the time map does not have the history. Okay, I see the issue here. So either we want to move that in there, or we create a new time map data that has these things in it. And yeah. A little bit. Yeah. I think we'll do this. let's just do this. Okay. Well, maybe just implement these because I want to have the same pattern going on here, and this seems like a good. So we'll initialize with. Well, we need the allocator size tiles. Let's just provide the same things here. And history. All right. So this is just gonna be the same thing. Alright, so now this is supposed to be the thing that is actually saved in the time map. It's the same thing actually, but now let's also do this, the clone. I'm just doing this for convenience here. Data, initialize, need allocator, history, initialize. Okay, there we go, and this one is time of data. All right. This one. Yeah, there we go. All right. So now, when we serialize, we actually we want to serialize the data. Now, this is going to be the pattern that we're going to have. Which is going to be common against among all these documents. So maybe we'll just put these in a separate thing. And this is the old thing that we have. Let's just remove that. I do have the history of that, so if I want to restore that, we can. So this will load in a time of data now instead. There we go. And then we don't have history, we have data like this. Okay. And we do have load. We don't have load. So we don't have the load function defined, but I guess we can add that as well. Do we have an no, we don't have allocator here. But it doesn't do anything right now, because I think that we're loading the tile set from outside. Alright. So now this is this instead. Alright. Okay. Now back to here, because yeah, we need to do a couple of different things here. So the thing that we got stuck on was the time map arena, which is now not actually used anymore. So I'm just gonna instead of copying these things, I'm gonna remove this, and I'm gonna copy the scene variant instead, because this one is more like to the pattern that we had, that new pattern. So I'm gonna copy those, and we'll rename this to create document data. Create default document data. And free document data. Okay. Yeah. This is now self, except does it need to be? I don't think it needs to be a pointer here. And this one does not need a pointer here. Because we're not mutating anything. This one does mutate, so we need to be pointer there. Okay. And here we have document. Document initialized. We need to rename this to document initialized. I'm not sure if I'm gonna keep this pattern, but I'm just reorganizing this for now here. Allocator. I'm just debating if I want to add an allocator to this editor or if I want to have it from outside. Let's just add it here for convenience, so we don't need to pass it into all the different things, all the different like methods and stuff. So just copy it there. Okay. Right, so now we have self.allocator everywhere. This one is wrong initialized. Okay. All right. And this one also initialized. This one is document. Why am I doing this? Yeah. And here we have also, right. So here we have like specific things for this thing. So we're creating a pointer to the document for some reason. Well, let's just continue with this pattern here. So we're creating a thing here. Then we're populating it with an entirely new thing. Also, this should be document type now. So it's generic. Right. We should probably... So we don't really know what init function this has. So that's the issue now. It's like, how do we actually initialize this? Also, we have load and stuff, you know. We could make an interface with a vtable and that sort of thing. Or we could also make an enum, a tagged enum, because, or tagged union, I should say, because ultimately, when we're gonna have this in the asset manager later, I think it's more convenient to have one type that you can loop through, have in a list and stuff, instead of having this. So this would actually be maybe even not a generic. Well, it's gonna be generic over one type of document, I guess. But this type could actually be, instead of a type like this, it could be a tag into. So let's say we have let's say we have a document which is a tag union, and then each type of document. So let's say we have scene. This is a scene document, and we have a time map document, animation document. So now we have these different things, and now we can define methods on this. We can define load. For example, we can define load here, and this one, I don't think, it just takes the document, and it will, now we can switch ourselves, and we can do inline else, document, and we can call load on self. All right. So now we have load. We can also do init. If, well, we don't have self. This returns a document. So init, actually, you could do tag for document, and we also need allocator. Let's try this. The thing with this is now we need all of these init to sort of only accept an allocator. Switch on. Oh yeah, this is document type, and we do inline else, and we'll do wait, how do you tag payload? So the type is document, the payload is document. Wait. Oh, it needs to be comp time. Sure, let's make it comp time. All right, and because if this is comp time, we can from outside have different ifs and else and provide the correct type from there. But now, yeah, the payload and then dot init with allocator. So what this does is given, it says there, given a tagged union type, which is this document type here, and an enum, which is the tag of that type. So we're getting this. So this is either like .scene, .timeMap, or .animation. We can get the type of the union field corresponding to the enum type. So if it's .scene, we're gonna get scene document. If it does timeMap, we're gonna get timeMap document, etc. And we can then call .init on that type. So for scene, we have init with allocator, so we're calling this function. And for timeMap, we're calling init. Here we actually can provide other things, so this won't actually compile. But I think what we're gonna do is we're gonna provide default values to these, so that when you initialize, it's just gonna use the default values, and then it can populate it later if it needs to. And we also have for animation document here, which has the same problem here. Wait, this is the same. Wait, what's happening here? Animation document. Oh, that's why. Okay, yeah, and this one also has only the allocator, which makes sense to me. Okay, so now we can actually call init. Well, we need to fix that time up document again, but let's actually do that real quick here. So we'll not provide these. We'll just say the default size. I think it's like time up init. Where do we do this? New time app. New size. No. Time app init. Oh yeah. Wait, now let's see. Size, time size. Wait, where is this called? Well, I know we have 35. There we go. So default size. Let's copy this over and put it here. Okay. Well, it doesn't need to be in data. It can be here. So default size, default tile size. It's not gonna change anyway. Well, the tile size is not gonna change anyway. But anyway, so now we have that. So now this conforms to the same. It's like an interface. It conforms to the interface. And if we go back here, and we go here. So now we can use this. And how you would use this now is if you have, let's say we're making a new timeout document, we can say document init, and we provide some sort of allocator. And then you would say the type of document here. We don't get auto completion here, which is sad, but we can just provide timeapp, and then that will actually initialize a timeapp document. So that's, you know, one way of doing it. It's like generating, or what do you say? Generalizing this sort of thing. We could even do the initialize as well, I think. But let's not do that for now. So now here we can actually say, instead of document type, we can provide a document tag. Well, document type is going to be this, but then we can say tag of document. All right. And we can say, okay, and the document type can actually be aliased like this now. So we can say tag payload from document to with the document type. Okay, so now this is actually, that's a type. You have to specify it like this when you, even though this returns a type, the color here, it doesn't know it's a type for some reason. Yeah, so now we have the document type. Back. And when we initialize, we can actually now say document initialize with allocator and the tag. So now we get, now this one, create document. It's not a type though. It's gonna be this. Okay, it doesn't, yeah. The LSP doesn't really no here, but now we have the document in it. Actually, this should return, yeah, it returns the document, not the document type. So actually, this should create a document and not a document type. Which might be a bit bad, because these things could be quite large or different size. If you have like many of one type, maybe this is a bad solution, because it's not gonna be very optimized by size, because a tagged union, if I'm correct, will take sort of the largest one of these, because it's a union, so it will take the largest, and yeah, and that will be the size of each document, even though you might have a document size which is just one U32 or whatever. That will still have the same size as the largest type of document. And if you have many of small document types, then those will still be like the largest size. So this might not be a good pattern for that, actually. Yeah. So I might rethink this a little bit. But it's good to explore, you know, the possibilities. 1 second here, I just need to eat a little bit. I'm gonna think a little bit while I eat here. Okay, so thought a little bit here, and I actually came up with a solution to this. We can still keep this pattern if we go in here and we change a little bit for each. We have a pattern here as well. So if you see here, we have a distinction on the data. So here is sort of the data that is supposed to be saved in a in the file. So this is the sort of persistent data. Everything else here is just fleeting data that is needed during execution of the editor. And if we put both of this one in its own pointer instead, and all of these in a separate struct in that own pointer, well then all documents is gonna have the same pattern. It's gonna have consist of 2 pointers, so they are always gonna be the same size, and it's gonna be less of it's gonna be less size if you want to keep all of those in a list, and they are all gonna conform so that they're not gonna take up more space in memory. Even though this might be premature optimization, but it's also forcing us into a sort of pattern that will very cleanly and very sort of obviously separate these two things. So we'll have the persistent data here and the non-persistent data here. So this will be, I mean, we could call this persistent data even. So that's the persistent data. So actually, since all documents are gonna be the same, we can create a separate type, which is called a document. Well, okay, so we already have this. I'm not sure if this is used. No. So we already sort of have this, I guess. Oh yeah, I was starting to make this, but I don't think, yeah, this is not used, but we can use this. So we can move the enum thing here. And here we also have like common stuff that is sort of also like outside of the thing. So yeah, this is more like the thing that we have maybe in the editor, but we do want to have these. Yeah, so let's just continue on this one. So we're also we need this generic document. So let's create that. We'll do documents generic.sig, and we'll create a document generic, but this is going to be a function, so this is going to take in it's going to take in the persistent data, and it's going to take in the non-persistent data. Okay, and we return a type. And now here we're gonna have persistent data and non-persistent data. Might be a better name for it, but there you go. And these are actually gonna be pointers. So yeah. Now if all documents follow this pattern, they're always going to be the same size, and it's just going to be 2 pointers, so it's going to be minimal for that thing. I mean, they are gonna increase, so to speak, by 2 pointers in size, since we need to keep those, but they are, so that's kind of the trade-off, I guess, with this, and also a bit more maybe confusing structure. But it's gonna be sort of keeping to the pattern, and now we can define a whole bunch of stuff with this pattern. So it's like an abstraction that I think should be good to have, because now here the idea is that you would define, well, we have this scene, but we also have, so let's have a pattern like this. Let's do document, scene, and then persistent data, and I will copy all of the persistent data here, and then yeah, and then we need to import some stuff. So we need the allocator, we need UUID, lib, vector, this one, array list, and that's it. Okay. And here now this one would be scene is equal to import persistent data, right? And we don't need you, we don't need you. Okay. Yeah, just checking the dependencies there. Okay, and then we'll also do non-persistent data, which we might rename to something else, like editor data or something. I don't know what would be a good thing there, but scene non-persistent data, I guess. And this would basically have everything in here. And so we need relib, we need this guy, Victor, we need standard, list. Oh yeah. So we need scene entity type from scene, no, persistent data, and scene entity. Yeah. Okay, that's the non-persistent data. And we might add like functions here as well. You can do that. So we'll have non-persistent data. I guess you could technically call this persistent data and have this, but it's maybe more like, or less readable to what is happening. And yeah, I think what you could do is you could use namespace document. I'm not sure, actually I'm not sure if you can do this, if it's just for functions or if you can get, also using namespace is, I think that's going away in future versions, so I think I'm just not gonna use it. What I was thinking is maybe getting in the generic document type here, and then using, I guess what you could do is say document, and then you can wrap it, like create a wrapper, generic, and then this would be scene and non-persistent data. And now you have these functions that are doing this. It just becomes so many layers now, so many wrappers and stuff around everything. I mean, I like the distinction of this. I do like the distinction of let me just add this one. I like the distinction of, if I can get to it, this one. This makes sense. This makes a lot of sense because you can just say the persistent data is the one that saves in the file. This is the one. These are things that sort of editor state, sort of temporary state. And so you can easily serialize this, or you can make this fully serializable, and you can easily serialize and deserialize it. This one is just initialized on startup and stuff, or when you load in a document, you just initialize it to default. So it makes a lot of sense doing it like this and having the documents separated on this like this, and that pattern sort of really makes sense. But it's starting to feel like I'm spending too much time on doing this stuff. But I know also that I'm gonna have a lot of different documents, so that's why I'm kind of spending some time on this to get a nice sort of pattern going. Maybe it's too early to do that, but I don't know. I feel like one of these things does make sense. I don't know if it's good to make a wrapper here, or if you just say scene document is equal to document generic scene non-persistent data, and then you would have maybe a wrapper on that. I'm not sure what is the good strategy here. It's kind of weird to have a document and then a field called document in it that has the thing where you're like wrapping that, but maybe it's fine. Because then it's like, okay, how do you access these methods now, the generic methods? Do you have to re-implement them here and then call those in there? I mean, I guess that's one way of doing it, because then the template could just be doing that as a base, and then you can add more to it, because it's not like it's sort of like trying to make a class out of this, but that you have the generic functions that sort of override or sort of derive from this generic thing, and then you can override them, whatever. Let's see. I mean, allocator actually has an interesting way of doing it as well, because you get different types of allocators, but they actually all have the same interface, but they have different underlying implementations. This is kind of different because we want to have the same sort of generic things, but then on top of that you have specific things for each type of document as well. So maybe it is better to just tap into the generic thing. So what do we actually gain out of this though? I mean, we get from my perspective, we're getting the structure of this, but what can we actually implement here as functions is the question. I mean, we could do init, dinit. Let's just go with this. We'll not put anything in here yet. I'll go with this for now. And I'll just redo this stuff here. So this is gonna be document persistent data. Wait. Oh yeah, document equals, and then see, this is also an issue because now I need to sort of make this alias here. I don't like this document. I don't know what to call this. Like generic or document. Yeah, it's really bad. It's really bad. Okay, let's just do the maybe document type. I don't know. I don't know. Document type. Persistent. I mean, we do get whatever it's called, auto completion for it though. And then non-persistent data. We can just do that, I think. Everything else is Alright, now I don't have that anymore. Okay, let's just import it from persistent data. Okay. It's gonna be a bit of a mess now, but I'm just gonna go power through this a little bit. So we have all these things, and this is also I'm gonna like do so that we don't have to do this mess as well. Now it's gonna be document and persistent data. Wait, yeah. So no. Go there. Document non-persistent data. Could have done whatever. Document persistent data. The initial. Maybe we should just do the initialize on the document. We don't really have a way to do that though. I mean, I guess we do have. We could just do this. Yeah. So we could put this in. Yeah, this is okay. This is one thing that is kind of nice because now, well, I guess I don't know if it's nice, but we'll put this in non-persistent data of scene. We'll have a deinitialize function. Well, it's kind of more localized, I guess you would say. So this is non-persistent data. Now we can do this. Do we have really this? Okay. So now we do this, and we can remove this, and we can move this here. There we go. And we also need allocator as well. Oh, we need to import that there. All right, so we have the initialize. Let's just add an initialize function. Why not? We're probably gonna need it. It's just nice to have this pattern. All right. And then we do the same thing we're doing here. We need allocator. There we go. And this one would just be non-persistent data initialize allocator. Right? And actually, if we keep this pattern, we could actually add a generic initialize function here, which returns self. And we accept an allocator. Now this is, now we're getting into sort of some of the nice things about this. I'm not sure if it's super nice, but we'll see. It's a trade-off, you know. It becomes more convoluted and maybe complicated in one way, but in another way it becomes more easy. As with all like abstractions, it's like if it makes sense, if it makes a lot of sense, it's probably a good idea. But there's always trade-offs. So well, but we'll try it and see. So hopefully it will lead to more productivity, and when we're implementing new documents we might run into the risk is running into roadblocks where you need something super different all of a sudden in a document, and that sort of turns the whole abstraction on its head, which has happened many times. But yeah, we'll try it and we'll see what happens. So this one we will just assume that persistent data has an init function. Also, this needs to be a thing, so a pointer. I wonder if allocator can actually allocate and populate at the same time. Alloc with options. Like, it's kind of weird that you can't, that there's like, you cannot actually allocate it with data. So I'm just gonna make a function initialize persistent data. We need the allocator, and we're gonna have persistent data is equal to allocator create. Why is this? Oh, there we go. Create, and then we pass in the type, which is persistent data. All right, we return this. Also populate it with persistent data init allocator. All right, and then we do the same thing for the non-persistent data. Okay, and now we rename this there. There we go. And I guess this could also be generalized, but it's just 2 copies here, so whatever. And we have non-persistent data, initialize non-persistent data, allocator. And I just realized one thing that you could do with this. Now, when we have initialize, we have everything there. You could actually generalize the JSON functionality of this as well. If you have the clone function also implemented on these. So actually that's really nice. Also load should be on, load can also be, so load is actually also on the non-persistent thing. Yeah, this makes a lot of sense. Okay, because now we can implement the whole serialized thing in the generic thing. So document generic, here we have serialize, deserialize. We will serialize. I mean, this is actually going to be the persistent data, yeah. And yeah, this is already, well, self is not persistent data, it's going to be self, but this is going to be the thing that is actually stringified. Let's dereference this just in case. So we're stringifying that, and I don't think you actually have to dereference here, but I'm just doing it anyway. And we'll deserialize, and this will become a self. And yeah, we get parsed, we get, this is the persistent data, right? And wait, this is persistent data. All right. And clone is now assumed to exist on this type. We initialize that. We have the document. It's going to be self. And then, oh yeah, and then this is self. Both of these are going to be, well, let's see. Here we're initializing with, yeah, we're just initializing here to the default things. We don't really need to do that. The non-persistent data, we can use this. So this should be good. All right. Well, actually, we need to use init non-persistent data because we need a pointer and stuff. Okay. And then the persistent data is set to, well, we can just do this then. There. But this one is not actually a pointer, though. Persistent data pointer, we should create that, and then we populate that with persistent data. We could do it like this as well, so yeah, so now we don't need, well, we can, I guess we can get rid of that. So now we have persistent data as a pointer instead. And then here we simply, yeah, because now that's a pointer, so that's fine. Why does it say unknown type here? Okay. Well, whatever. Right. So now we're doing the same thing here, except it's generic for all types of documents. We can call load on, now we have to call load on non-persistent data. Well, the thing is with this load is we might need the persistent data because that might refer to stuff that we might want to load, like a texture file or something like that. Like for animations, that's going to be based on a texture. That's going to be based on a sprite sheet. So we probably need to pass in the persistent data here. I think we'll make that as a pattern. Well, it's just called scene in this case. It doesn't need to be mutable. Yeah, we already have a dependency on persistent data anyway here. Okay, so but we're not using it here, but we are gonna use it in animation, I think. So yeah, now we have that. Cool. All right. So we have a lot of stuff that we don't need to specify or implement for each different type of document anymore. So that's really nice. Let's see here. All of these are specific though. So deinitialize, we can probably just call the initialize on document itself, and then provide this function. Persistent, wait, now we need self. Wait, why am I not getting this now? Oh, right, because it's a type that we don't know anything about. But we're just gonna assume that this is the interface. So again, if we go here, we have the initialize, so yep. And we go to scene persistent data, we have initialize. Although this initialize looks a bit different, so we have position and entity type, and that we don't have. Yeah, we don't have that. Wait, this is scene entity though. That's not the same thing. Here we have initialize. Yeah, okay. That looks good. We have the initialize, we have clone. Okay, so this is sort of the interface that we're gonna have, and load as well. Wait, well, not load for the persistent data. This is the, yeah, so this is the sort of the interface for the persistent data. And then for the non-persistent data, we have initialize, deinitialize, load, right? We don't need to clone since we're not loading in this from the JSON file. Okay, cool. So now all of this we don't need to specify for each type of document, so we can just call the initializer document with the allocator, and here we actually can also do this document type initialize with the allocator. All right. And that's going to be the same for all types of documents. So this is like, we're not going to have any more fields. So we might even yeah, this is how it's gonna, these two functions are not gonna change, and we don't need to do load or anything. Serialize, deserialize, we reach into the document itself and do that. Yeah, right. And then all other functions, so basically just gonna reach into persistent data or non-persistent data. So this is gonna be non-persistent, so this is gonna be like document non-persistent data, and yeah, it's gonna look a bit messy here. Maybe we wanna make like a function that does this more simply. I don't know. Let's do it like this for now. All right. We need scene entity type as well. All right. Yeah, we're gonna have a whole bunch of errors that we need to fix before this all works out. But we don't need to do every document like this for now, even though we should probably do that. Yeah, we should probably do that. Let's see. So get texture, that one's fixed. This one doesn't have anything. What else are we accessing? Well, we're gonna get some errors that we need to deal with, but where's like all the access to the persistent data? Here's where we have. Why am I not getting this? Okay, there we go. Selected entities. I mean, selected entities. You could do this also. You could do selected entities, like get selected entities. I think I want to have this convenience function for documents anyway. So this will be whatever this is. Array list C entity. Oops. Return self document non-persistent data. But we need self as well. Self document dot selected entities. Get selected entities. Yeah. Wait, get selected. Come on. All right. Delete entity. Persistent documents. Yeah, it's a bit more messy, a bit more. But what, get time map file? Oh yeah, because we have a time map, that's fine. Okay. All right. So I mean, this file is less now, but we don't. Yeah, as I said, we don't need the serialized init, and the init is a lot nicer now here. And but then again, you have to go in here to see where it ended up. But it's more compartmentalized, I guess. It's like pros and cons. Yeah. Okay. But anyway, let's do the same now. I'm just gonna go through here, see if we need to clean up anything here. Where are we? There. Don't need you. Okay. There we go. Now let's do the same for time map. So we're gonna need to do persistent data, and this one is the persistent data. All right. Yeah. Alright, and history. that's it. So that's the persistent data. And if we go to scene, we copy this. We need document generic, and we need time data. Where's the persistent data? Whatever, persistent data. And we also need non-persistent data, but we don't have that yet. So we don't actually have non. Do we have? Oh yeah. Oh yeah. The non-persistent data is actually part of the context now. So I think it's time to actually break that out. Well, it's gonna be a lot of changes here, but yeah, I think it's gonna be worth it in the end, hopefully. Okay, non-persistent data. And this is for the time map. So I'll just put this like here for now. And there. Okay. And the document now is should conform to the same thing here. So this is the document type. Then, oh yeah. So now actually we need the default things in here instead. There we go. Default size. Nice size. There we go. Alright. So this one would be document and then document type. Oops. Initialize without. There we go. And simple enough. Clone. Wait, did I move? Oh yeah, we don't need clone on the document. So let's remove that. Yeah, I don't think this is not used. Let's remove that. We don't need load either. On the document, we have it on the other thing. And serials and deserials, we can just remove this now, so we don't really have that. Okay. And now this one is document, persistent data, history. Alright, and this one is document. Persistent data. Why? Okay. Persistent data. There we go. Cool. So this one is a lot simpler now, which is really nice. And then, yeah, we have a bunch of stuff in here, but that's fine. Most of the logic is actually in time map itself. And non-persistent data. We need to actually move a bunch of stuff in here now. So let's split this, go to context. And we have a whole bunch of stuff now. So tools, this one for example. We need to, I'm probably just gonna move this over here. Okay. We do need tool now, so let's bring it in there. And brush tool. And select tool. There we go. And we're probably gonna also move this because this tools is like, it's also like super specific for the time map editor, so we're probably gonna reorganize that as well. But let's not do that right now though. Okay, and also this document, I'm just gonna move this to document. I'm just gonna move it here for now. Content, I guess we could call it maybe. Yeah, I don't know. Wait, we don't need. Wait, this is call time, so we don't. I don't think we actually need. Yeah, we don't need to do that. I know we're trying to solve another issue here, but I don't think we need to. Since this is comp time, we could just do type payload directly here to get the type out. Yeah. Yeah. There we go. All right. Right. Okay. Back to context. And let's ignore this for now. So we're not gonna have the time map arena anymore. So let's just nuke that. Current file name we already have. Background color is for all things. This we should probably just nuke. We do use it here. I don't think we really need this. I mean, okay, let's just keep it for now. It's mostly for like learning about ImGUI. Camera we need. I guess it's camera is like specific for each editor, so we're gonna probably we're gonna move that to each type of editor. Here we have the current tool and tool. So these are gonna be moved into the non-persistent data. Tools is sort of like a source of. I don't really like how I did with the tools. The tool system is really weird. But this thing is sort of like the source of truth for the tools. We have this array here with the tools that is sort of like a mutable. I don't know what it is. Well, I don't know what this is actually. We're basically copying this. No, we're sending it to. Yeah, it's like a mutable weird thing. Wait, why am I not? Okay, there's something weird with the LSP now. Everything goes there. There we go. Yeah, it has a name. Yeah, it's like an interface. Name and implementation. And the implementation is also set here. No, but this is brush tooling. So yeah, I don't know. I have to rethink how to do this weird thing. Let's see where the time map non-persistent data. So, but I'll just copy this over for now. All right. redeclaration. Okay, I'll just ignore that for now. We have textures. So here we actually have a sort of a texture container here. I'm not sure if we actually do use this. I guess we do. Maybe. I think maybe I started to use it and started to implement it, but it never... Oh yeah, I have the tile set in there. Right. But I don't have anything else in there. Okay, so that's nice. So this is sort of the beginning of sort of like a resource management system. It's just a string hash map of textures, but it's nice to have a one place where you have stuff. Okay, and here's the documents that's going to be in the editor thing. Scale doesn't matter. This is part of the thing here. This one is also in there. This one as well. These two are... They should really be in here. But I'm not gonna change that right now. Yeah, I think that's it for the non-persistent data for the time map editor. Okay. Now let's see. So, what do we need? We need an init function that takes an allocator, I believe. So we need allocator. Should probably make like a template for this as well. And yeah, and this returns this. And it returns this. Okay, so what do we have? What do we need to do actually? This one we can just set to null directly. And I guess that's it, so we don't actually need anything. We don't need the allocator either. Okay, now we have deinitialize. I'm not sure if we actually need to deinitialize anything. We do have the action. Oops. Can we go here now? Wait, no, action. It does have a deinitialize itself. Yeah. Okay, so we do need this. Wait, but do we deinitialize this? It's a materialize an action, yeah. So this action is actionally. Yeah, we can't call it. The thing is, yeah, I think it doesn't really matter. I think it's the thing with materializing action is that it's an action that is sort of currently, it's not complete yet. So it's like when you start to draw, it starts an action, but it's not fully sort of materialized yet until you're done with drawing. Then it creates the full action, which is then stored in the history. But during materialization, you actually, well, we saved the snapshot from before, but the only way for that action to not materialize is to basically crash the program, and then it doesn't really matter anyway. So we don't really need to deinitialize this. So we don't really need to deinitialize anything here. and we don't need, yeah, so we don't need to do anything basically. Okay, what else do we have for non-persistent data? Let's look at scene here for inspiration. So we have load as well, and let's grab that there, and here we have persistent data. I think I want to go to the pattern of calling it persistent data just so that we don't have to like rename it everywhere. Okay, and then we have a load, and don't think we really need to do anything here either. I mean, we're gonna need to load in the tile set that is used with this specific tile map. So we do need to load that into the textures. Let's see. Where is this actually done? In main? Okay. So we're kind of hacking this in here. In main, after we've initialized the context, created that, we put the sort of hard-coded tile set name in there. But what we want to do is read the tile set name from the tile map file and then use that to load in the texture. I'm not gonna change that right now. It's gonna be on a to-do thing. So here we'll do to-do move tile set texture loading logic to here, because the thing is we already have we have the persistent data. So if we just say data and we have the tile set here. Wait, where is it? Oh, we don't have it. We're not specifying that. Oh, right. So yeah, what we do is we have layers, we have tiles, we have tiles. Wait. Oh, this is a layer. Wait, no, this is a layer. Yeah, this is an array list of tiles. Is this a bug in LSP? Yeah. Anyway, this tile has a tile source. And this tile source has a tile set. So each tile in the grid can have a different tile set. So I think what we want to do is we want to manage a list of tiles, or when we save, maybe we store the tile sets that are needed in a list. Because otherwise, when we load, we have to go through all the tiles and compile a list of tile sets from those tiles, instead of just saving them. I mean, you could do that as well. It's just a matter of, yeah, what you choose to do. But anyway, so we need to get all, number one is get all the tile sets that we need to load from this, all the resources that are needed, and then load them. And that sounds like a very generic thing to do as well. So it's each document type has dependencies, which are resources or other documents or something. They could be different types of dependencies. You can have dependencies that are sort of, yeah, we absolutely need to load this before, and maybe, you know, maybe we can have like something like that. You could have more loosely dependencies that is like, we don't need to load it in now. We can load it when we need to, when we want to draw it. We can load it in. So you can have like lazily loaded in stuff as well, by having sort of a wrapper around a texture that is like a lazy loaded texture. So it has a file name and it has like a state if it's loaded or not. And then when you request sort of the image out, it will say, okay, is it loaded? Then provide the loaded image. Is it not loaded? Provide sort of a standard not loaded yet image, and then have it load in, and then it will load in as well. You can also have a pending loading state where it will not initialize, you know, initialize a loading if it's already loading and stuff like that. So there's a way to actually make this pretty nice to work with. But for now, let's see. Move tileset texture loading. Yes. What do we want to do? I mean, we just want to basically... I was thinking of maybe writing something down here, but I'm not going to do that right now. So that's something for the to-do, is like make a resource management system that does these things. That you can specify is in a generic way what dependencies a resource has, and then those resources can be loaded in on demand and stuff. But anyway, let's see. I can even make it so that you can use the same system in the game as well. So because it's gonna depend on the same data, it's gonna depend on the same like JSON files. You can actually move that into a library, and then you share it between both the editor and the game. So that's actually a nice like shared functionality that you can have there as well. Okay. But anyway, yeah. So we're just gonna assume that we have the tileset loaded in, and when we need to use it, we access the textures in context instead of in somewhere else. All right, which we already do, so that's good. Right, so we've moved everything in there. We have all the functions that we need to have. So now we need to rewire. Well, first off, let's go back to document tilemap here. Let's go back here and see if we need to do anything here. I don't think we really need to. We might want to copy some functions over. I'm not sure what we want to do. But now let's go to... We want to do the same thing for animation document as well, though. Maybe we should do that right real quick here. Animation document. Yeah, we have it here. We need to specify document type. We need to get the generic there. And then let's start persistent data. Yeah, let's start just using these terms. We'll have persistent data here. This is the persistent data. So we'll just copy that. We'll copy all this stuff. Animation, we import that. What else? There's nothing else here. Cool. And it already implements all that it needs here. Cool. So that is the persistent data. Did I misspell it? Oh, persistent data. Wait, I need to do this. Okay. I'm not sure if that's a good idea because it kind of decouples, or yeah, it's not really apparent when you're in here. You have to look at sort of where you are in the file structure to understand maybe what you're looking at. So I'm not sure if this is a good thing to name it persistent data in here. I don't know. Well, whatever. Let's just do it for now. Alright, so now we need also the non-persistent data. Just making sure that it's the correct name. And what we need there is basically everything else here. So we need these things. Not sure about the allocator here actually. We don't need the arena. We don't. Let's just remove this. Okay, we do need. Wait, we don't need this either. Okay, there we go. Right, and now we need a init function. We need, yeah, and this needs the allocator, which we don't use. Come on, allocator. And we need initialize. Oops. Actually, we need self. And we don't need to do anything. What else? Load. Yeah, same thing there. All right. Unused. Yeah. Okay. Very simple for now. It might extend in the future. Okay. Let's remove the allocator here. Let's just keep the same pattern here. Document. And remove these. And document. No. Man, I really hate that auto completion for allocator. Allow 0? What does it say? Allow 0. I don't even know what that is. Anyway, so document, initialize. Let's just pass the allocator here. Keep to the pattern. Load, we don't need serialize. So these ones now we can just remove, and there we go. Very simple right now. What else can we get rid of here? We have this. We don't need you. Okay. There we go. Oh yeah, and we need non-persistent data as well. There we go. Very nice. And now that is done. So no errors in here, no errors in here. Okay. Right. Okay, so I think now back to the context. We're gonna have like we need to fix context and the layout functions now, or files. So it's gonna be a whole bunch of different things. So, oh yeah, and we started on this doc. Maybe we should finish this one as well now. The editor. I think I'll just create a new thing for that. There. Alright, so document type, that's gonna be from document here. Yeah, document content. I guess we could say document tag. That's not payload. It's tag document content. I'm not sure exactly how this will turn out. It feels like we have a wrapper around a wrapper around a wrapper almost, but yeah, so but it also feels like this is the way to do it. But let's see what we can sort of peel off the onion shell, which shells we can peel off later. But the document type, this is going to be the document tag. Maybe we should call it tag instead. Type. Yeah. Tag. I don't know. Type makes more sense in like a generic way. Tag is like very specific to this type of, you know, specifying that specific type of thing here. All right. Let's just keep it with let's keep it with type for the name there. Otherwise, I'm a big proponent of calling that variable name the same as the type, but in this case, it's such a small, silly thing as well. It's like it's not really necessary to be that picky. Okay, so let's see. So now we have that. We can actually import that now. Tag. The thing is, wait, no, it's not going to be. Yeah, we have it here. So now we can specify. Now we can say document tag. Use that. Maybe we should call it type. But then it collides with the other thing. Okay. Let's just keep it tag for now. Right. We need allocator. Oops. We need what type of document? So the document, what would this be? That would just be the document, I guess. Like this. And why is it in a pointer? Doesn't really need to be in a pointer. I don't think. No, not with this like new way of doing it. I don't think. This is just gonna be a couple of pointers, and now we have name and file path. So we actually don't really need. I'm not sure if. Maybe we'll just keep it as a pointer for now. Make it. Just so we don't have to change too much right now. And here, oh yeah, and also here's the document type as well. Yeah, okay, so we have the document type. Why do we need that though? We probably don't really need that. No, because we're creating a document and not a document type, right? So we're returning this, yeah. So don't actually, I don't think we need this. Right, and what's happening in here, like, we're creating an, yeah. So this is very specific for the scene. So we could provide like a hook or a event handler here, like on create document data or something that populates it like this. We could also handle it when it's initialized as well. But this is when we create a new sort of thing. I'm just gonna put this in this like this for now and keep the things that are sort of generic. So we have document in it, document. We don't have document in it. Oh. I guess we do this. So we do have content, so we document content in it. My brain is like automatically going into JSON mode a bunch of times because I'm so used to that. Okay, allocator, so we need that. And the document type. Oh. Okay, yeah, we'll just provide it here. Why is document tag not? Wait, didn't I create that? Wait. This is. Wait, where did that go? What? Didn't I create this thing? Right? I did create that, right? Maybe it got deleted somehow. Weird. Okay. Anyway. Right, so now we can provide this here. Fine. We have name and file path as well. Do we need that right here though? Because we might not always have those things. Because, yeah, it might be a newly created thing. Name is also... Yeah, I think we'll just not have this for now. We might add it later. But the file path is actually good to have because yeah, then we can, although this is also the file path, so maybe we don't even need the file path on the document itself. No, it's good to have. I think this is gonna end up in the asset manager, so I think it's nice to have the file path here. But the document content might actually not be loaded, or the assets library might have like a let's say you have like a resource, and this resource has a file path. It might not actually be a file path, it might be something else. We might have like a union enum whatever, but it has some sort of file path maybe, and then it has the content, which is also a nullable, so if it's null, it's not loaded. And then this is actually a function that takes the content here, the content type maybe. Something like this. or maybe this is a pointer to an NOPake, or so that you can have this in a sort of list as well. I'm not sure actually. Maybe it's a union tag union. It's like a wrapper around the document. I mean, it's sort of the base same thing as a document, except it's more generic maybe. I don't know. Maybe document should actually be resource instead. Well, we could make content nullable so that it's not necessarily loaded. So it's like, yeah. Like this. Although it's not necessarily loaded when you do this either. It's just initialized. Yeah. So this actually, it's not actually loaded here either. Like all the, yeah, it's just initialized into the thing. But we don't really need it to be initialized though. Right? If we just have it as a, this basically have it as a file name in a assets manager library list, and then we populate it when we load it. So I think this makes a lot of sense. We don't need to initialize it here. Don't actually need to do anything in here. Okay, and then we have deinitialize. It's just gonna be, I don't think we really need to deinitialize. Well, I don't know. Let's just have it for convenience. And well, actually, you know what? Let's not actually have this for now. So we're gonna implement it when we need it. Okay, 1 second. But what do we select? Okay, let's leave here for now. We have the document there. We probably, so this is like the current document. We don't really need this current file name because we have it in document already. And we probably want to have this, like if we have an assets manager, or a resource management thing, we want to have these documents as part of that. Oh yeah, because resources can be documents. It can also be like images, which is not really a document per se. I guess you could define a document as a, but document is more like what I was thinking more conceptually. A document was like something that you can sort of edit in the editor, like a animation, yeah, something that's saved as like a JSON file, not like an image and stuff. But I mean, yeah, I mean, you could technically define one second. All right. Yeah. Okay. Whatever. I think I'll just basically treat document as anything that can be opened or anything, any sort of resource that you can have, because we can, if we need another content type, we can like an image, we can just add here. We can just add image, and that's an image document or whatever, and that's gonna just implement the same interface, but it's gonna be for just the image. And when you load it, it's not gonna be, I guess it's not gonna be deserialized though from the, oh yeah, it's not gonna have the same serialized and deserialized stuff though. It's just gonna be a resource that's not supposed to be edited in the editor. So it's just gonna be loaded in. It's like a immutable resource. Maybe we'll have something. Yeah, maybe we'll have a distinction there. Okay, but I don't really need to think about that right now. That comes later with the like resource management system. So yeah, so the editor is basically, it's just gonna have everything needed for the specific type of editor, or for generic stuff for the editors. And the document itself is gonna keep sort of the editor state for that specific document as well. And the pointer here is gonna, later is gonna be in, as I started saying earlier, like in the resource management system. But right now we don't have it, so it's just gonna be a free floating pointer that's gonna be like sort of created here and then removed when it's not needed. So when we create document data here, we create this thing. And this initialize, yeah, it's just doing this. We don't even need anything in here. Actually, this is kind of weird, because the content can be any type of content. So you can actually you can like switch out the content of this document, which is that's kind of weird actually. Yeah, I'm not sure what a good way of doing this is. Okay, 1 second there. Okay. Right. Yeah, okay, I'll not worry about that for now. I was just thinking, like, what does this do? This just doesn't do anything, and we don't really need to specify the type. We can do it later, I guess. We don't load anything because we don't really have anything to load. We don't have any sort of, yeah, we don't load. Yeah. For scene, it's like it's hard coded. We're loading in these things, so that's why we did it there. Let's see. And this one just this. Okay. Free document data. If it's not initialized, we return, right? I mean, we could just have it as a nullable instead. Because, yeah. It's like the editor exists without a open document, which makes sense as well. But now we have a lot of guardrails here. I mean, this is technically a whole bunch of nullables. And so we probably don't even need it to be a pointer though. It's like it doesn't really make sense it to be a pointer right now. I think we'll just do this. And we don't even need this now. The initialized thing. Free document data is like, yeah, we don't really need to destroy it. We don't have the initialize. We could implement that. Like self document. But it's like if content, I guess if we have it, we initialize it. We don't have the initialize here. We should actually just be able to do this. And self we don't have a type because yeah. And then we just do switch line else. Like that. Alright. And it's not going to return anything. Okay. Alright, I guess that's it. I mean, file path might need to be destroyed as well. So, also we need to pass in allocator here. Yeah, so now we have the initialize there. We don't need this, we don't need you. It's, yeah. I guess we can also set this to null afterwards so that we don't do the same thing again. File path, I mean, where's that set? It's not really set anywhere from here. It's yeah, it's set whenever you do like save and open and stuff, right? So it's basically gonna be set once for the for each document. How do we want to do that? I mean, I guess if we can just say this, if we have it, fine, then we will free it. Okay. If we don't have it, we don't care. So, and then we also set this to no. Okay. I mean, that should be good enough, I think. And then, yeah. Like, why would we need to call this? It's like if we want to open another document in the editor, that's the thing. But I don't think, I mean, the way it's gonna work later is like right now we have like a separate like open file, new file, save file for each type of editor. Later we're not gonna really, I don't think we're gonna have that. I think what we're gonna do is if you want to create a new tile map, let's say, you're gonna go to the assets manager and you're gonna like right click or click on create new thing and create new tile map or tile map. And then you name it something, and then you're gonna double click on that or something, and you're gonna get into the editor like that. And you're not gonna have like, you're not gonna open up from the editor. You're not gonna click on new there. You're gonna do it through the assets manager, just like in Unity and Unreal Engine and stuff. But yeah, so we're gonna do that when we get there. It's just I'm trying to sort of juggle a couple of ideas at the same time, it feels like here. Okay. Let's see. So yeah, I mean, sure. Okay, so that's some things in the editor. Let's go back to context and see here. So we do want to have, I guess we want to have like a list of editors that are currently like open, and then when you like, it could be a window, its own window. It could also be like a window within the editor window, or it could just take up the full screen. I'm not sure actually. And then the assets manager is always maybe, I mean, I'm trying to think of how this would look. Like, it would be nice if the assets manager was always visible, and then you have the current editor seen at the rest of the screen, basically. You could do that. That would be like an easy start. So, because, you know, yeah, you're not gonna be able, I mean, in GUI actually makes it really nice to work with. Like, you can easily add more windows, like add a window that you can move around and stuff. But I think for now I'm just gonna sort of start with like a maximized, well, not maximized in terms of the operating system windows, but the like inner window is not gonna have like yeah, whatever. I just talked myself out of that one. So anyway, now we're not gonna have these. We're not gonna have like current file name for each one. Instead, I'm thinking we could have sort of, let's put it here or whatever, editors. So these are sort of the opened editors. Opened editors. Current like open editors, which is gonna be an editor. Oh wait, but now we have a problem because it's like a different document. Okay. Actually, since this editor is sort of like a generic editor, we probably don't. We cannot really have a list like this. Yeah, we can't really have this. Okay, let's make this a simple type here instead. Okay, so like this, and then when we create the data, we don't actually need a thing here. That's interesting as well. We don't actually, yeah, we don't need anything here. We do need, I mean, in somewhere in here we're gonna need the document tag, but right now we don't actually need it. So okay, anyway, now we can use this. So let's also go to lib, and no, not this one, and we will have the editor as well. Alright, now we have access to that through lib. Editor. Okay. Alright. And this is gonna be an array list. Let's do unmanaged. Unmanaged is gonna be the I read that the array list unmanaged is gonna be the default. So they're gonna switch around. The array list is gonna be the unmanaged version, and then you're gonna have a managed version that is gonna be the one that it's not the default one. So I'm just trying to use unmanaged everywhere to make it compatible. Because we're gonna upgrade to 0.14. I'm not sure if they did it in 0.14, but 0.14.1 is 98% complete as of now, as of recording. So yeah, once that is done and released, I think I'm gonna switch to 0.14. That's gonna be an interesting upgrade to do. Okay, because I want to keep up with the versions of Zig, because yeah, to keep the also like the videos relevant for the current version and stuff like that as well. People who are interested in Zig. Anyway, so open editors. Yes. Now, camera. I think we want to. I think camera makes sense in some editors, but on all, so I'm not sure how to deal with that yet. I'm not sure how to deal with specific editors yet. But we'll get there, So we don't have this. We do have editors. Array unmanaged. Editor. Init capacity. I mean, they are not that heavy, so I'm just gonna initialize with something there. Right. So now we have a bunch of those. I'm just, you know, moving along here. It's gonna be a lot of changes that we need to do. So, oh yeah, so we need to remove this. These things we're not gonna have anymore. We're not gonna have this. I mean, I'm not gonna touch this now, but current project's not really used anymore. This is fine for now, I guess. See here, we don't need these. What we can do though is we can loop through all the editors now, and we can say editor.initialize. Wait, what's happening? Oh, items. Don't we have the initialize on editor? Nope. Okay. So let's create that. Self. I mean, okay. Now we can replace self with editor. And we'll remove this. Alright, self. Document. Initialize. I don't think we don't really need to save the allocator here. Actually, document probably needs. I mean, let's just initialize it. Why not? I mean, why do we? We don't really need to do this. Okay, and create document area. So this is basically we want to sort of deinitialize the current document. Oops. And then we just set this to wait. We just initialize it again. We don't need to do any of these things. And then we just return documents. We don't need to. This doesn't need to be that, and we also don't really need this to be. I mean, if we go to context and we do create blah blah blah, like why? Oh yeah, we also have these. Oh yeah, so we need to. Yeah, we need to copy this as well into editor. This is where it's actually used now. So we have new file scene. So let's just call this new file. And I think we need this to be that. So we're setting the current scene file name to null. So we're deinitializing that. We don't really need to do that. We just need to deinitialize the document. Okay, and then yeah, we don't have allocator, so allocator. Wait, do we need the allocator here? Yeah. All right, and then document is equal to create default thing. We don't need to do this. If it's seen, do this. Okay, yeah, so this is a kind of special behavior since the editors are sort of intertwined a little bit. If you're in scene, the thing is, if you're doing new file, you're kind of gonna see the tile map in the background. So it's like it. Okay, I'll just delete this and we'll deal with it. But anyway, so this is new file. We're freeing the things that we have, and then we set this to a brand new document. So that's all we want to do with new file. All right. And you can see that these two are very much the same, except here we also do a new file time map. So we don't actually really need to do any of this. So let's actually just remove this. Okay. Now we have open file. Oh yeah, open file we don't actually have either. So let's see if we can just we'll just take these two, put them here, and we'll fix them up. So this will be let's save first, and this will be open file. Okay, right, NFD Let's import that. Yeah, we need node here. We need, well, this is going to be editor. And yeah, the file filter. That's gonna be depending on the document type. So I think we can actually grab this from the document itself, like the document content even. These could implement their own sort of things for that. So we can have this generic thing with file filter. So we can have like pub const file filter is equal to whatever it is, scene file filter, scene.json. Yeah. So that's the file filter for scene. And then we have animation document. So this is going to be animation. Is it animation or animations? It's animations. Yeah. Alright. And then what else? Time app document. Right, so that's that, and now we can go back here and we can provide a function that's the get file filter string, and this is going to be the document, and we're going to do same thing here, switch inline else document, and it's going to be a type of, because it's a declaration, so you need to do that. You could also have a function that you call on the instance as well, but whoops, we don't want to look at the error list. Not yet. Okay, so now we can go back here, or the editor, I mean, and we can say, instead of scene file filter, so we'll just get file filter like this, and this is, well, open file. Okay, so we need to know, oh, this is gonna be an issue. We need to know that the document type now. So yeah, okay, I didn't think this through enough. Well, we have the document content. We don't have the document content. That's the thing. We need to. We have the type. We have the tag. We can get the type from the tag. So we could do document payload and then the tag runtime is a, well, no, this is a document tag, and we'll return a type, and we'll return tag payload content tag. Okay, that's the payload, right? So we're getting either scene, time app, or animation document from that, and then you can use that to grab actually we could do this also. We could do now I'm doing this like a million different things, but it's like everything is new, so I have to like explore these different options here. So what you can we don't need to have a self here. What you could do is you can have a tag instead, document tag, because it's dependent on the type and not the instance. So now, well, we get this. I'm not sure. Do we need a 0 sentinel for this? I'm not sure. Well, we'll figure it out later. But from this, we can actually do switch on tag, and we'll do inline else, and we'll get the tag. No, wait. What am I doing? Wait. Can you switch on a tag? Also, this needs to be comp time. What's happening here? Tag is a type, yeah. It's either type, yeah. So, oh yeah, so we just do return and document payload. We can use this one now. So, and then file filter. Okay. And if it doesn't exist, we could make, you know, if has declaration document payload tag, and the name is file filter. If we have it, we return it. If we don't, we can do. If we don't have this, then we can do like a compiler error, and then say whatever thing doesn't have that. But in my experience, the compilers are, well, actually, now that I'm not using this weird report system that I had before, diagnostics in NeoVim, maybe this will actually work better now. So it wasn't reporting the error in the sort of an easy to find way before. So, well, now we can say document content, and then tag name tag, does not implement the declaration file filter. There we go. Okay, so now if we remove that, well, we want to call it first, so this is going to be document. I guess we could add it on document, so we could have it here, get file filter, we return document content, get file filter, tag, right? And then here we say get file filter from, well, it's gonna be whatever tag. Oh man. Okay, so we actually need to store this somehow here. Do we have to have it in the type? It's a type. It's like a, it's not, well, it can be a tag. It's not really comp time. Okay, maybe we can store it here. We can store like a document type. I mean, we do have document here, but we don't have the document type, though. This is just such a weird organizational issue here. But anyway, let's do it like this for now. So this would be the tag. Okay, so we're keeping it there. And then, yeah, when we initialize, we actually want to provide the tag. So tag. But the thing is, when you when you open the editor, it's gonna be this weird sort of middle ground now, because before we have the assets manager system, or after we have the assets manager system, we can actually provide the full document to the editor, or the full, or the the document type to the editor before it's created. But now we're sort of creating the editor first and then populating it and calling open from the editor. Yeah. So we're not gonna do that later, so it's gonna be like a refactoring later where we move that stuff outside. We basically have a generic open which opens the correct editor for the specific type of file, and the type of file is going to be stored based on, I guess, file name. Yeah. Okay, but we're gonna have to do it like this for now. So we'll store the document tag in there if it's possible. I'm not even sure if it's possible to do that. We're gonna be able to store it somehow. You can also grab the tag name and or to make it into an integer or something like that. Actually, maybe that's, well, let's do it like this for now, and we'll see if it complains. If it's like, it has to be comp time known, and it will make it into an integer if it has to be, if it can't handle it. So let's see, where were we now? Right, we get the file filter when we open the file. We get it from self document type now. There we go. Okay, now we get the file filter, so we can use this here. Okay, we have default path. Default path is actually going to be provided from outside, from the context. Maybe we should put the context in here as well. Or we just provide it here. I guess we could provide default path. Well, it's not really, well, it's gonna be like the initial path or whatever. Okay, and if we have the file name, we free the, we defer free the path, we open it, and let's rename this. So this is going to be renamed to open file X. File name. Okay, let's call this NFD file name because we'll get it from NFD and we need to handle it with yeah, we're duplicating. We also need allocator. Do we have that here? No. There we go. Alright. So it's not self.allocator. Okay. Oh yeah. Let's see. Okay, yeah, so we're here. We open a file, could not open file, that's fine. This is new file instead. Why is it try here? This doesn't have anything tryable. So let's do that. this one though. Yeah, we're catching the error. Do we have anything that tries in here? Do we have this one? Why is that try? This shouldn't be a try here. And this one is also try because it is the same kind of thing. So we don't actually do this. Oh yeah, this is also a special case with scene. So we open the time map. So the scene actually, that's actually the most sort of complex thing here because it can depend on other resources, which in this case is the time map. So it actually opens up the time map in the other editor in order to utilize that sort of resource. So maybe we could just, you know, put the okay, yeah, I just thought of something that solves another issue, but yeah, I think when we open the scene, it's not gonna open this in the other. This is not gonna happen. What we want to happen is we want to load in the time map into the resource system and then access that resource from the scene editor and draw it on the screen. That's what we want to happen. So I think I'll work towards that actually with this whole refactoring thing. So we might actually get to making the resource system as well, like a rudimentary version at least. I mean, it's basically just going to be a hash map into a document. Yeah. And what I was thinking also is that the editors also could be a hash map because each editor is gonna be specific to one document. So it's like if you open a new document, it's gonna open a new editor. But if you open a document that already open, you don't want to create a new editor. And how would you find out that there's already an editor of the specific document? Well, you can have a hash map that goes from the file name to the editor. So yeah, that way you can look, okay, do we already have this open? Okay, then use that. If we don't, then you have to create a new one. Alright, cool. We don't have initialized. We don't set the file name like that. So what are we doing here? We open the file. Yes. We close it. Afterwards, we read it with a JSON reader. Yes, we initialize the reader. We free the data. Sure, fine. Right. We also, this is not gonna return an error, and this is not gonna be a try. The document is populated here, which actually we want to populate the content, and yeah, we have these things. So the content is gonna be document deserialize. Right. So this is now we're starting to tie up the bag here, as we say in Sweden. So let's see. Yeah, so we want to have a sort of deserialized thing here, I think. Let's think this through. Not too much, but a little bit. So, well, we could have maybe a load here. Or like open. I mean, let's try it. If we have, let's say we have open, and then this is view, and of course allocator and file path. We could do this as well. We don't really need all this in here. So yeah, we're getting a bit closer to the source here. We're getting open. The document is and I mean we don't really need you. We don't need this for opening a file. We can provide a document, but we don't need to have a document to open. If we get the file path here, we can say, yeah, we can just do everything that we do in here. But we don't need to do this. We open the file. Okay, let's rename this path. Okay. It doesn't matter. Okay, we're doing everything here. So we don't need to do this now. We just create. Well, this is. It's just gonna be a document. And file path is equal to file path. And so we don't need. So that we don't even need to. We don't need to like. Yeah, the ownership of file path is gonna be transferred to this. And then what else? Content. What's happening here? Yeah, content. Content is gonna be document. Deserialize reader and the type, right? So we need like the type of the thing. Not tag, let's make it type. And then should it be no, not comp time this time. Okay, so then we have this. We might catch an error here. Yeah, so let's do that. Okay. If we have an error, well, actually, let's have that at the top, I guess. So we will say try here. So this is actually, this makes sense now. This is a try, yeah. because then we bubble that up and then we handle that outside and we don't set anything there. Okay, so that makes sense. Now here we do want to duplicate the file name and stuff. We don't want to free the file name though, unless it burns here when we try to deinitialize it. So we're not freeing it here. Do you want to try here as well? But there's like two different errors happening here. I mean, we could also return error. Do this. Catch. And return error. And then here we do, well, it's gonna be document. Well, first we're just gonna do free document, which, I mean, it's just doing this, so let's just remove this function, we don't really need it. Okay. So we deinitialize the document, we do open allocator with file name, and the document type is gonna be this, and then we catch an error here. And if we have that, we're just going to return new file. Okay, so we don't need this. We don't need any of this. And we also need to free file name if it fails here. Okay, but if it doesn't fail, we don't need to free the file name because it's going to be stored in the actual document itself. Okay, cool. Right. So now what? We have some errors issues here. Alright. And I think we can just return this now. Yeah, we'll just return that. Okay. It's a bit clearer also with the error that can happen. There we go. Okay. Now, so yeah, so now we need a deserialize function here. So let's make that deserialize. And we don't have anything yet, so we're gonna wait, load document. Okay, this doesn't work, but let's not worry about that for now. So deserialize will return a document content, I believe. Yes, it should. Right? And it takes allocator, JSON reader, and yeah. Let's just search for this. Deserialize. Yeah, this one. Okay. What else? Oh yeah, and here we also need document type, which I'm not sure if we can, since it's a type, I'm not sure if we can actually pass this here as a runtime, but we'll see if it works. Otherwise we have to like pass it as an integer and convert it. Okay, so now I think we can just do switch. What's happening? Oh, macro. Switch on. Wait. No. Oh yeah, I think this has to be comp time actually. Could we do switch on the tag itself? I mean, what we do is we do switch on document type. We get inline else. So here's the tag, and then we do payload, and we do. Yeah, I think we actually, yeah. But anyway, this is what I'm thinking. So we do document payload, and then this one will have a DCLS, which takes allocator and reader. Actually, it won't. Wait. No, this is like the old thing. Wait, no, this is generic. That's right. So if we go to document, scene, document, this doesn't have a deserialize. So what we'll do is, but everything looks the same. It's gonna have a document. So what we'll do is we will say I think we say init. Okay, I'm a bit lost now. Do we do initialize? So I think we'll do this. I think we'll do content equal to no. Well, okay. Document payload and then initialize. So we initialize it. Which will do that, but we don't actually want to do that. We want to deserialize it. Yeah, we deserialize it immediately. But then the issue is that this init function might do something else. So I think what we want to do, if we want to have something that happens after init, yeah, I think we'll put that in load in that case. Yeah, okay. So in that case, I'm not sure if you follow my thought process here, but I'm like thinking of a million different things at the same time. So this would be not init, but just deserialize. Yeah. Okay. Yeah. Just. Oh wait. No. It will be like this. Document. Yeah. And then this one is document payload. It's actually gonna be let's see. Let's actually make document type public. Yeah. Let's make this public, because then you can go in here and you can say this is the type, so you can say document type dot deserialize. Yeah. There we go. All right. Okay, and now we need to do that for the other things. Let's put it in here and make it public. And this one as well. It's also nice to work out these things now, and we only have 3 different documents, so it won't become a huge refactoring later. So it's kind of good timing to do it now as well. It also feels kind of nice that we've come so far with editor that we want to do this right now. Well, we'll see if it pays off, but it might not. But we'll work through it. Okay, so now we have this. I'm pretty sure we need to change this. I think the edit compiler will probably complain here at some point, but well, it's gonna complain on a lot of things. We haven't hooked any of this stuff up yet, so the compiler isn't even running here yet. So, but now we're calling this with open here. So we have that. What we don't have is save. I don't think we have save here yet, so we need to copy that over as well. Save file. Yeah. Scene. Save file scene 2. There we go. We need both of those. Okay. And this is gonna be editor. And probably mutable. Let's see. Right. So we're checking here if we have file path. Okay, let's rename this to make it consistent. If we have a file path, we want to save file to save file. Okay. Right. And here we have the save file dialog. We need the file filter again. Luckily we can grab that. We could actually just have a get file filter on the editor itself as well. So we can just do this. And this is an editor. We'll just do self document get file filter self document type. Alright. And now we can actually say self get file filter instead. What's this? Unused capture. Okay, let's just remove it. And here we don't need to grab it. We do self get file filter. Right. So now we're send. Yeah. Okay. So here we have this thing. Oh man. So we basically want to have the file filter plus a dot at the start, which is like super annoying. But okay, file filter, and I guess what we could have, document, we could just have, I mean, this is constant, and this is comp time. Let's just have a thing here. So let's just do get file extension, comp time tag. Was comp time, so we'll just return get file filter, and we have to, and then we'll just append this. Since this is in comp time, you can do an append, comp time append like this, or string concatenation. Well, it's actually an array concatenation, and yeah. Well, and since strings are technically arrays of bytes, just like in Haskell, it works. Okay, so anyway, yeah. So now we have the file extension as well. This one is defined on document, so that's cool. We can define it here as well. Extension. So this would be extension. I'm pretty sure this won't work because this is runtime and that's not runtime, so it will actually fail here, but we'll fix that when we get to it. Oh. Okay. What? No errors here? Okay. Well, we're gonna have a million errors to fix in the layout file and in the context file. Okay, now we have moved save here as well. Let's see, yeah, there's a bunch of stuff to fix here. Default path again. Let's do initial path. And there. Let's do, now this one should be get file extension, and here it's not runtime, so right, we actually we need to do this. Is it, do I have to, like, am I gonna have to? No, I might not need to actually free this thing. Like, this is gonna be a comp time thing. It's just gonna be a bunch of switches on. It's gonna compare the tag type, and it's gonna return a constant, a read-only thing. So that should work. Okay. Right. And we do save file to, and then, oh yeah, and then this one doesn't really work, so it's going to be document.file path. What about the old file path? Right, so if we have a file path, we just save. If we don't have a file path, we get the file path, desired file path from the file dialog, and then we populate it here, so you know that we don't have it yet. And let's call this file path for consistency. And then we save it to the file path that we have. I wonder why we don't do that. Oh, we actually have it here. Okay. Wait, what did it say before? Oh yeah, it's the equivalent of this. Right. So, but when we open, we should also set it. But I think we're setting it here. Yeah, we're setting it here, so that's fine. All right. Okay, I just want to finish this function now, and then I think we have most of the things that's supposed to be in here. For now, at least. Oh yeah, here's the file name. It's actually 0 Sentinel. We have to fix that later, but everywhere else. I don't think we really need to have this log here. Let's remove that. Try this. Fine. Do you want to catch that? It's gonna crash otherwise. It's the issue. So I think it's better if we catch it and print an error. Is that log error? Could not save file. And we return with nothing. So we couldn't save it, so we don't really do anything. Is it gonna close the file? Oh yeah, I guess if it's error, it's closing it automatically. I hope, at least. Yeah, because we're not getting the result there. Okay. And then we have a writer and we serialize it like this. So I think we should probably, do we have deserialize here or in the content itself? We have open. Maybe we should do save as well in that case. I mean, it makes sense to actually have save also. So okay, I just need to remind myself what the responsibility of open is here. So open, it opens the file and it deserializes it, and now what's the responsibility here? We just basically get the file name, and then this one we have the file name, which is supposedly an NFD file name that we actually duplicate. Let's not call this NFD file name because we're not using NFD in here. Well, okay, I understand why I renamed it now, because okay, I just did this not too long ago and I'm changing this, but okay, so this is like the file name. What to call it? Okay, let's just do this. freeing it. We're duplicating it, so there we go. Well, it's basically deinitializing the document and then setting it like this. Okay, and for file, save file, we basically do the same thing. We get, if we have a file path, we save to that. If we don't have, we get the file path. We also modify the file path a little bit, and then we save it. And then down here, we open the file, we write to it. So we could do the same. We could do sort of the same thing actually in here. We could just do save, and this will be a document and file path. It won't be try in that case. Yeah, I guess this would return the error. And then yeah. And self content dot serialize. Wait. No. Wait. Yeah. But if we don't have the content, then we can't save. So if we don't have, if this is null, then we just return. And I guess we can print an error. We have to have, like, this is a good place to have an error. So I'll just make a new one. This is gonna be document error, save error, which is no content. Right, so that's an error, and here we do this. We don't have serialize yet, so but we could just add it here. Serialize comes first due to the convention from before. Serialize takes a writer and itself, and nothing else, and then we switch ourselves and we simply call serialize with writer. That should be good. File name. It's called file path here. There we go. Alright. So here we just basically just do, I mean, let's just try, I guess. Try self save, well, document save, whatever, let's call it file path. There we go. Okay, no more errors in here. Right, so are we finally ready? Let's go back to context. I think what we'll do is we'll just delete everything here that has to do with opening files and stuff. Yes. Yeah. It's gonna be a lot. Save. We don't need these. What's this one? Set current scene file name. Like so much logic just to set the file name, and it's yeah. Default path. Okay, there we go. We're down to 359 now in context. That's good. Set tool. This is yeah. That's gonna be specific for time map non-persistent data. Yep, cool. Tool type. Yeah, self current tool. Okay, get tools. Probably also here. Yeah. Let's do that. Non-persistent data. Okay. Function. Oh. Yeah, I'm not sure what this is about, but okay, cool. I'm just checking all. Yeah, squash history is also that. Actually, that's gonna be in. We'll move that to the time app document. Also engineered action and stuff like that. Although these things are probably gonna be put on the history itself, maybe. Start action. What is this? Restore session. Okay. Let's put that in the time app document for now. Document, no, non-persistent data. Alright, we're gonna have end action. Document, no, oh, this is persistent data. And the allocator. We need then we need that to be passed from outside. Okay. 1 second here. Okay. Right, let's continue with this. Non-persistent data. Whoops. Input, yeah, that's a non-persistent. I'm not sure why the auto-completion bugs out like that. Right, this is persistent. Okay. Wait, under redo. We already have under redo. Can undo. We don't have that. I mean, I guess we could do this. Just make things a lot easier. Get history. Document, persistent data, history. Oh, this is. Yeah, I'll do that. I think since this is a pointer, well, yeah, I think we can just do that. We don't need that to be mutable. And then we can also do get timer, which is just a thing. Alright, so now we can say get history, and oh, this one is also like, oh, this is just gonna be get timer. Materializing action, let's this is an action. Wait, but here we're setting it, so whatever, let's not do that. Okay, here we can do get history and get timer. Why did we do that? Yeah, so undo so this is like on the editor level, sort of. We could probably keep this logic and put it in here. Yeah, we'll just put this logic here. If can redo, and then we undo, but then we also do this. Oh yeah, so we sort of do an update on that. Okay, hang on. Let's see. Where was I? So let's see. Document. Okay, I totally lost my train of thought here. Yeah. So we're updating this. So we can say get time up now, get timer for its size, that's fine. And we'll do the same thing there, I think. Is that, idea, so we'll just remove this now. Oh yeah, and also the allocator. Yeah, I already fixed that. That's right. All right. Yep. Right. Now here we just say get history. Undo. Get history can redo. Why? Oh. Document. Okay. Comp time. 1 second here. Yes, generic action type, materializing action, non-persistent. Why is this not working? Is it because it's like a generic type? It's having problems with the auto completion. Although once it's done, it's like, yeah, okay, yeah, I know that exists. It's like, it's weird. Okay. Snapshot before. That's basically just get timer like this. Yeah, we copy that field name. This should be the same. Oh yeah, it's this weird thing. We need action. Right. And the allocator, again, it's just normal allocator, which we can grab. Now what's the convention? Is the comp time stuff first, or allocator is always first and then comp time? Usually, I don't know. Let's put it here. Alright. Now here, time out document. I'm not sure if we ever need it to be mutable now, since the underlying things are always pointers. Get the action, we do, yeah, so this one, the allocator as well. Alright, and then timer. There. Squash history. We do, oh, this is called context here. And we do get history. Initialize. And here we actually need to set the history to a new history. Why couldn't we just, well, we could do get history. Since this is a pointer, we can do this. Right? Do you need an allocator? No. Okay. Cool. We moved a bunch of stuff over there. What else do we have? Restore session, play, store session, create editor session, default path, free. This one we don't need. We don't need you. 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 Deinitialize. Free file time of data. No. And no, but we do want to move that to time map non-persistent data. We actually have stuff to do here now, so yeah, I think that's it here. We have the action, but that, we don't care about that. Current tool. Okay, so current tool is the only one we deinitialize. I mean, I guess I don't care. Should we set it to null as well then? Yes. Okay. There we go. And load will not do anything. Yes. Okay, fine. We don't do this. Yeah, we just call the initialize on editor. It will call the initialize on document, which in turn will deinitialize the content, which just deinitializes the data and stuff. Yeah, and the file path will also be deinitialized. So that's really nice now. Although I do think we want to change this to a hash map instead. Maybe like a hash, like an array hash map or whatever it's called. Okay. Yeah, I'm just gonna take a quick break here. I'll be right back. Alright, I'm back. I'm gonna have to take a longer break soon here, but probably continue a little bit after that as well. Okay, so where were we here? Okay. Finding the path again. Yes. Did we cover everything here? Okay. I mean, there's gonna be a lot of issues. We made us a lot of changes. And it's gonna be, yeah, it's gonna be a lot here. So it's also like we need some way of switching between the editors. Like right now we just have this list. Do we actually need to implement a little bit of the asset manager as well? And the resource, maybe just do that and we'll be done with it. With that is the resource management system. So that we can define dependencies as well, loading them in. We'll have the assets manager, which will sort of, you can add file locations, maybe you can add like a directory, and it will look through the files in the directory and add those as resources, which are not loaded, but they are in a list, a hash map. And then you can open through that, you can open up an editor. So you will populate this hash map, which will be, let's do array hash map now instead. String array hash map even. Or auto. No. String. Unmanage. I don't know. Let's do that. Which will, yeah, to editors. Okay. And I think we're just gonna do this super simple here to start with, just so that we can get rolling on this. Now, what type of init do we have? We have, yeah, this is what's super weird about this. Like, why do we need to provide a key list and a value list here? What's the purpose here? Is it just to populate it with something from the start? I don't really understand this. Otherwise, I think you can just initialize directly using default field values. Yeah. So you do that if you want just an empty thing. But if you wanna, I guess, initialize it with some read-only stuff, maybe, then you can do that here as well. So you have like a, almost like a comp time thing, right? Maybe? I don't know. Okay, so, but let's do that. Okay. And then, actually this would be open editors. Right, and then here we don't have items, we have whatever values, maybe. Yeah. So you can iterate through those. Yeah. And this one, it's unused. Right. Let's just remove this. We'll deal with that later. Okay, so hang on a second. My cat is going crazy here. Okay, not sure what's going on. All right. I'm sure it's fine. Right. These things. Oh yeah, so we don't have this anymore either. We don't have these. It's nice to just remove a whole bunch of weird stuff that you have. We don't have this. We don't have that. We don't have this. We don't have that. We don't have this. Do we have this? No. This is also really nice. Just to remove a whole bunch of dependencies. Okay, editor we have. We don't have history. This one we should have. We don't have this. This, and this, and this. So that's when you know you're, well, know is a strong word, but the kind of feeling that you're moving towards getting better organization of the code. There we go. Okay. Right. Now what? I think maybe we could start with maybe it's time to do the project thing. It's like you're opening a project. The project file sort of manages the whole thing. It makes sense to do that now. It's kind of, this has like always been this looming thing. It's a huge thing. We need the assets manager, but it's going to be easier to handle all the assets when you have a project, because the project can hold all the asset thing in it. It's going to hold all like linked folders and stuff in it, or even just copy everything into the project, having everything in the project folder, which makes sense. I think Unity works like that. It's like, yeah, if you drag in an image, it's going to be copied into the actual project itself. I mean, you could have that. You could also have that it doesn't work like that, like it's just a link as to a destination, so it grabs whatever's in the destination and shows it up in the assets manager. But I think I'm gonna start there and then maybe have things later in there. Okay, but what we could maybe do is, suppose we already have editors working here, we could now start to change the editor layout functions, or yeah, to work with this new sort of structure. So yeah, oh, we also have this thing. This thing, restore session. Oh yeah, this works. So restore session is going to be interesting. Maybe it's probably going to be easier now. We don't really... Okay, let's do this here actually. So, well, the session here, session is gonna change as well. We're gonna have like the current open documents maybe. And the current editor. Maybe just one editor. Maybe it's just the thing that you had opened last will be also opened. We'll start, maybe we can start there. Right? So we have like opened editor. It's gonna be the only thing that's there. And I guess we could just have like a open editor, and it's a file path. This is maybe that can be the same thing here. Okay, so that's the file path, and it's gonna be also like a document type because we don't really have that. Could maybe map. I mean, we could do this. We could go to the document. We could go down here, and we could say here. We could do get tag by file path. File path. And this would return a tag. So basically, we are going to check switch on the tags, given an enum or error. Right, switch on. Wait, switch? No. Inline 4. We need to loop through all the sort of the tags. Tags. Yeah. And this is document content. So, given an enum or error set type, returns a pointer to an array containing all tags for that enum or error set. So, we are getting a tag out. Wait. It gets the tag. What about... Right, so it's the tag, but it's not like a... It's... Does it contain the entire thing? Takes the fields. It sets all the things. Field T. Okay. Wait. Yeah, I'm not sure. It's I don't think, yeah, it doesn't return only sort of a tag version. It returns the actual tag. I think. So this doesn't work on tagged unions, I don't think. I don't know. Man. How do we get... So what I want is... I want to loop through all the tags. Well, I guess we could try this. I know we get... But this... It says document content here. That's weird. Well, I guess we can do... If... We can do type of tag dot file. Well, we can do get file filter on tag. Okay, and then yeah, it's just gonna end with this. Extension. Right, and then we will say if if, and there's a thing here, no, ends with, and if file path ends with extension, then we return the tag. Otherwise, it's an error. Okay? Alright, I have to go in like 5 minutes here. Okay. Right, so that's the basic thing that I want. So get tag by file path, and if we have that, now we don't need to store the type of document here. We can just look at the file name and figure out what it is, because they're all gonna have like different types there. Okay, so now what do? We will go, and then the other thing is like, sure, that works. Back here, so we don't have these. Oh yeah, one thing that we could do is we could have a current editor. And it could be a pointer, it could also be an index, it doesn't really matter, I guess. Let's make it a pointer just to make it easier to work with. I guess it's a nullable, and we'll set it to null. Okay. Right. And then when we create the session, we can use that to store this. So current, what is it called? Open file path is gonna be if current editor. Why does that not work now? Okay. We can say file path, I think, or document file path. Else, what else? I guess null. Yeah, because we don't have. Yeah. So I wish there was a way to do this more simply, like in other programming languages. I'm not gonna name any. You can do question mark dot document. This one has it, and then file path, and then this will actually be either null or without, so it will all work out. However, you cannot actually do that here. Like if you try to do dot question mark, this will try to unwrap it, and if it's not null, then it will crash. So you have to do like this: if blah blah blah, blah blah else null. Right. Can remove those. All right, and that should be it there. Then for store session shouldn't actually be any different here, I don't think. Yeah, but for restore session, this is gonna be different. So if we don't find the file, we don't really need to do anything here. No, we don't do this. Thank you. So we don't really, well, if file is not found, then it's not an error. That's right. So we don't really do anything, I guess, is the thing here. We don't restore any session or anything. Okay, that works. And it's also interesting that you can do this, because you can define an error, and then that somehow matches the error that has the same name. Because the issue here is that this function returns an error that is, it can return several different file not found errors from different sort of error types, because there are several of them that's named the same. So it's easier to do this. However, it also means that if you haven't I mean, if they do a breaking change and rename this, you're not gonna see it until it crashes on you. So but anyway, I need to go now, so I'll just pause here and I'll be right back. All right, I'm back a little. Ooh, excuse me, earlier than expected. What's this? A bunch of weird stuff. Okay. Been on it for 5 hours. Yeah. Yes. And my brain is starting to take note of that. No, it's fine. But yeah, let's see. Restore session. Yes. All right. Yeah. So we're doing a major sort of refactoring and implementing stuff. I'm just gonna continue here. So where were we now? Yeah. So restore session. So yeah. We're reading in the thing. We don't need to do these things, which is nice. And here we have like, okay, so if we have a file name, we open this. If we have so we don't need to do any of these. And also, we don't need, yeah, let's just do this. Yeah, so here, if we have a, whatever it was called, open path thing, open editor file path, we do, we get the document type is equal to document. No content. What is it? Where do we have it? Maybe we'll do editor. We can do like let's say we have editor and we have like open file, but that requires an editor though. Yeah, actually, we don't really need this anymore. So we don't need self here, I think. It's gonna open always with the file name. And remove this. So we can actually just return an editor here instead. All right. So yeah, then we don't need to deinitialize. We don't really have a document thing, and the document type is gonna be this. Okay, so we're gonna get tagged by file path, and the file path is here. Oh, let's actually call this file path. All right, so that's the type, and then yeah, and then we pass that in here, and then can actually, yeah, that's runtime. And if it fails, we need to free the file path. We do new file. We don't have self, so we don't really need to do that. Well, we actually I guess it's an error. Yeah. Okay. Now here we also don't really have an editor, but we will return one, and we get the file name, and we don't do self. Okay. Yep. Very good. So in then context, we can now say editor open file, and that's our editor. And if there's an error, I guess we will catch it and then log this error, could not open file, and the file path is there, and then the error is there, and I guess we just return. Or we can return the error, because how do we handle this error? Could not restore session, right? So we should probably just return the error here. So if we can't read it, we should also return the error, right? And this here, yeah. Open, yeah, so we remove this. We don't really need to do this, okay, because, yeah, we don't have an editor like that anymore. Okay, now what? Parsed, we're deferring that initialize there, right? So if we open any editor, we had some editor that we had open, we try to open the same file and we create a new editor from that, we need to populate then the editors. So we need to put, and since we're restoring session, this is the first thing here, so we're just gonna assume capacity here. And it's gonna be this file path, and it's gonna be the editor. All right, because this is just, yeah. All right, cool. Allocator. Wait, isn't that just self allocator? Okay, there we go. Okay, I think that should be it for that. Can this be an error? No. I mean, it can, if the capacity is not what it is. It's gonna be like a error, right? But it doesn't check the capacity here, right? Yeah, don't know. Okay. So we're gonna have this editor. Oh yeah, and also the current editor should be the one editor that we have. So it is a pointer. So it's gonna be values. Wait. Yeah, I think it returns to backing array. Modifying the map may invalidate this array. It is permitted to modify the values. Okay, yeah. So the issue here is like we're storing the pointer, which now is bad because if we open more editors and it like needs more space here, this will become invalidated. This pointer will become invalidated. So it's probably not a good idea to store it as a pointer in that case. So we will store this as a usize instead. And we will have a function that's called get current editor. And I guess we could have a pointer there. And this one would return self opened editors values self current editor. If we have one, I guess. So if current editor, and then we get current editor. So this would be the index. Else we will say also what you could do is I have to be better at this using or else, which is a really nice pattern as well. So you get I equals to self current editor, or else return null. So we'll do this, right? Because then we can just return this. I think this is a lot nicer here. Okay. So now if we actually want to use current editor, so this one is just 0 now, because we only have one. And where else are we using this? Here. If we have current editor, then I was just thinking if we could use it here as well. I guess we could do file path. It's like open editor file path is equal to current editor, or I guess current editor is equal to wait. No, okay. So I want to have, where's the store session? Create editor session. Oh yeah, so wait, what did I think here? Oh yeah, so now this is an integer. So we actually have to do get current editor instead. There we go. Wait, but we don't have. Yeah, we do have self. Okay, I was mixing this up with the init function. They look sort of similar. Okay. Right. Now, what now? So, I guess this also means that all documents actually have a file path. It doesn't make sense that this would not have a file path now. Because you can never really open the editor and create a new thing without a file path. You always create it from sort of the asset manager first. But I'll keep it like that for now, and we can change it later. I just added to do here. Remove nullable when we have asset manager. Okay. Also the content is can be nullable because it's not necessarily loaded. So also deinitialize, we could have like unload, which will only deinitialize the content, but we don't really need that right now. Okay, so now I think the session stuff is done and dusted. Play is next here. So play is a bit weird, I guess. It would sort of imply that, well, either we can make it so that, I'm not sure how Unity or whatever does it. I think that one has like, it's always like the scene that's opened. It only has one scene open at a time, I think. And if you open any other editors, they are sort of on top of the scene editor. So the scene editor always there, it's always like in the background. And when you press play at any time, it's gonna run the thing, the scene that's in the background. But as I'm building it now, I'm sort of opening up the possibility of having the scene editor, like multiple scenes open at the same time. So then how would it make sense when you press play if you're in sort of, let's say, an animation editor? But it would be kind of annoying to have to go back to the scene editor each time you want to test. Let's say you're editing the animation and you just want to do some quick changes and then press play and then test it out and then testing it again. I don't know. You have to go back to the scene editor each time. The correct scene editor as well. So how would you find that also? It's like, should we have, I mean, you could have a list of open editors, I guess, and have like a tab system, so you tab between the editors, like the open documents. I mean, a tabbing, like alt tabbing, but control tabbing inside the editor instead. Not like, well, I guess it could be actual tabs as well. So that's sort of old school. Okay. Well, I think we'll start there and we'll see. Maybe we'll lock it down to only having one scene open at a time. I don't know. It would be maybe, I mean, I understand also, like, it's very resource heavy probably to have multiple scenes open at the same time with these big 3D games and stuff. So maybe that's why they do it like that. But it's also nice from a user standpoint, I think, as well. But okay, anyway, I think we'll just do it. We'll just have this pattern that also when you press play, it's like from the scene editor. You're not going to be able to play from any other editors. So I think we actually need to move this thing to the scene editor instead. Or we can keep it here and then say if get current editor and then we will say if the type is equal to scene, or if it's not equal to scene, then we return. But otherwise it is, so we will do whatever we're doing down here. So don't really have, so let's just copy this in there. It's kind of bad it's getting nested now, but well, actually, okay, we'll do this. Editor is gonna be, yeah, okay. I just said that I need to get better at this. So if it doesn't exist, then we return. So now it's not nested. Okay, now we still have the editor here. Okay, but it's not nested. Cool. Yeah. All right. So we need to change these things. Right, we're saving the thing so that it works. I think maybe we'll go through all of the editors and save them in this case. And I think it's pretty easy actually. We'll just do self editors and values. Oh, we get this open editors, and we can say save file. And now, since all of them should have this file actually populated, it's gonna be fine actually. Default path. Wait. Now this one. Okay, yeah. So we can do this. So we'll go through all editors. We'll save them, and if something goes wrong, I guess we catch it and we will error it out. We also need to implement so that this becomes very easy to spot as well. If something goes wrong here, it's just gonna not do anything. Well, I guess it could be error starting. We could say cannot error starting starting game. Well, error saving, and let's do this. Open editor. We have the file path here. I'll just force it there. Wait. Open editor. File or document. And then error. And then if it's erroring, we'll just return, but we'll also set play state to error starting. Okay, so we'll remove these. Right. And then we are launching Zig here. We do need the file name for the current scene. and that's gonna be editor. All right. So we're launching that stuff. And what's going on? Okay, yeah. Yeah. Yep. Okay, cool. So that should be good now. Right. Now, I think most of this file is done. So we need to head out to layout now. There's gonna be a lot of changes in here that we need to do. So yeah, let's start at the top here. Right. So yeah, we don't actually have a scene document like this anymore. So what we'll do is we probably want to define a new function for draw editor. And I'm not really sure if we need the context. Well, we'll keep the context there. Editor, we'll just do this. Oops. Where is this thing? Okay, so we'll do switch on editor, and let's just assume that the content is loaded. Yeah. And here we have scene. So we can do draw scene document. We get the context, but we can also provide the scene here as well. And same for time map and animation, but we don't have draw scene animation yet. But we'll just do. We'll just make one. Animation document. Animation document. I'll just do this. Mode doesn't really matter. It's gonna yeah, so this is gonna be draw editor, and the editor is gonna be get current editor. Well, I guess if we have one editor here, we are going to draw that. That's a pointer as well, so good. And then we don't do this. And we're gonna do the same for the other thing here as well. But let's go here. Okay. Just distracted a little bit. Okay. Yeah. And let's do time map as well. Document. Document. All right. Let's start with maybe time map, easiest. So yeah, this is gonna be document get. Wait. Get, yeah. I was wondering what happened there. Let's do this. Time map. All right. I guess we could have like a time map get size or something convenient instead, but it's not a big deal right now. Draw time map. So this one definitely we wanna put the time map there as well. I think this is just a wrapper around here anyway. Well, it's wrap around a bunch of draw layers, I guess. So we need the time map like this. We don't really. Do we need the context here? What do we? Textures and scale and stuff. Okay, yeah. We need to change the stuff in here as well. But let's just do this one first. So we'll put the time up there. Let's do pointer find. Okay. All right. And then current tool. So current tool is going to be from the edit. Well, actually, it's document. Yeah. Document. Wait, what's happening? There's gonna be a whole host of compilation errors, but I'm not sure what. Nothing. Oh, there we go. Well, there are some stuff there, but it's gonna be creeping up like a whole bunch of stuff. Let's see. Draw. I guess we could fix sort of the draw things first, and we can sort of we can do this for now. So if we fix the draw things first, well, actually nothing will sort of happen because we don't have an editor. So also there's problems in other places here as well. So, but we'll focus on this one first. Maybe we'll even only do tile map for now and get that working, and then we'll see. So else we're not doing anything. There we go. We'll go in here and, well, we have the tile map. Actually, maybe that's a good point. Maybe we don't even do this one either. We just make everything sort of work from like, yeah, get editor and stuff. Yeah, let's do that. Unused, so let's do that. Okay, now let's go and fix all these things. Yeah, origin. So that's gonna be a vector 0, 0. Okay, is that it? Invalid left hand. Oh, what's this? Okay. Expected that. Yeah, so redeclaration. Like, where is this redeclarated? This is local to this file, so I'm not sure. Like, I'm pretty sure you can have the same name for different types of structs. This is only for this file. Like, I'm not sure what the issue is here. I mean, we are importing this. That's not an issue. Redeclaration. Let's just try. We'll restart this thing here. And save. Do we get the same issue here? Okay, I think that disappeared now. Open file. Oh yeah. Wait. Right. So what is the file filter that when we open a file? Because, right, so we are actually not opening a file like that anymore. Let's actually do this, because we're not actually gonna call this one anymore. So expected found document. Okay. Now where is that? Like, I don't see. This is the issue here with compile errors. It's like it shows where the compiler complains, but I want to see in my code where it actually calls this function and gets the compile error. So, like, where's the source of the error? Who calls this function to make it an error? Which is maybe not an easy problem to solve. I can understand that, but if we look, I mean, if you would look at the, I think you do get like a trace, but it's not showing the other things. So let's go to document, because I believe we are calling that somewhere. Right. So this is apparently not a, well, okay, it is a struct actually, so it should be content. But now we get this one. So question from enum document contact. Right. Okay, now again. Now we're getting some errors here. Right. This one wants allocator. Fine. What? No more errors in here. Okay, we've got string coercion to, oh wait, this one is, oh, this can be an error, so put this catch and reachable there. Expected, wait, action, what happens? Found void. What? Clone returns nothing. Oh, return. Oops. there. But then this one returns. Oh. Action. What is this? Wait, can you get the tag from... Wait. I mean, we do have it in comp time here, so you can do... So we'll return... wait, wasn't it union in it? Union is an action. The active field name is tag name action, right? And then what the hell's this? Okay, I guess we can just do this, maybe. No? Can we do type of? No. Well, but this one expected. Can we do self? Active tag, what the hell is this? Turns the active tag of a tag unit. Yes, that's the thing that I want, right? Type of U as tag, okay. So we have a enum interfloat and then a tag union here int float. Right, so this is the tag type, and then we have a union instance, I guess, here, which is of type int, and then active tag becomes this. Okay, so we'll grab the tag from self because it's the entire thing, it's not the thing here. So we don't really need a switch here in that. Well, we do need action, but we can do this. And then we return this. with that, I think. But that's not comp time. Is the issue is that it's not comp time, right? Yeah. So we need to, well, we have this inline else. But can we get, because I was hoping to get the tag out of this somehow, but I guess we can't. Converts enum value or union value. Right. Could we do this? We have cloned, and then we say, so the issue here is we need the tag. We need to know which tag it is, which we cannot do because we're inlining else here. But we don't get the tag, we only get the value. I wonder, can you get the tag out like this? Oops. No. Let me look this up real quick here. Sig switch else tag. It's the capture thing. Like, yeah, you can sort of define all the different actions here, but I want to capture, because this will basically split out all of these. I mean, I guess what you could do is say inline 4 and then tags of document content. Wait, no, it's not document, it's action. And I get the tag here. Okay, I think you can do this instead, and then say if tag is equal to, oh, that's, yeah, this is a tag, is equal to active tag of self, then I think you can do this with integer, like an index instead, though. Like, isn't there like a tag, like index, like field index? Yeah, field index. And then this is like tag name. But then this has to be... Oops. This is not comp time. Does this require? This requires comp time, right? Or maybe not. And then so that's the index, right? So we're gonna no, but this has to be comp time. Yeah, okay. That's the issue. But couldn't you get the index from tag sort of index, wait, int from enum? Right? And then the field, but then this is not comp time. But you could, wait, will this work? I don't think so, right? You would have to have a switch, I think. Switch on I 0 to, can you do open? Will we get something out here though? Well, we do have I guess. I is the thing. But in this context, it's like a comp time thing, right? Right? No? 0 to, I mean, I'm just gonna put 1,000 here. Now this one is unknown. Okay, what about I? Okay, that's weird. I guess it's because I is unknown, I guess. Okay, now this should be fields action X, right? And oh yeah, they oh no, this needs to be inline. Does that work? I guess you could do this length. I feel like my brain is betraying me here, but okay. Let's see. So now we return. Now I want to create this action, this enum value. Yeah, so return union init on action. The active field name is now field.name. And the init expressions okay, this is actually, we can grab the action now from field access of self and field.name. So now we have the action, and we can say action.clone. And right. Okay. I guess else unreachable. Will this work? Index 11 outside of what? Do we need to add one here? Or -1. There we go. It works. I mean, it compiles. Okay. So, right. Let's just recap here. So we have a clone function of a tagged union. And it returns an action, the same thing, but all sort of pointers inside is gonna be different, located somewhere else. So this is like, we want to find which tag from all of these does it have, but we cannot use like active tag because that is a runtime thing. This is runtime, so we're basically turning this runtime into a comp time thing. But how do we do that? Well, we get the int from enums. This is a runtime. Then we have a check here. We have a inline switch that goes from 0 to the length of all the fields in action, which are all of these. So yeah, I think it was 10 or something, 11, yeah. And so this goes from 0 to 10 then, because there are 11 fields. And we get this one out, which is now sort of like a comp time known integer. And we're using that to grab out the correct field, because this needs to be comp time, I think. So, because if, let's say, we don't have inline here, I think this will be a compiler error. Yeah. So now it's not comp time known anymore, because it's not inline. But we add inline, so now it's sort of like copying this code for every possible field. And then it knows that for the first field it's going to be 0, second field is going to be 1, and so on. So we grab out the field here. So we now have the comp time known name of the field, that we grab the payload of the tag here, and then we create a new union value with the type there and the name of the tag, which is now comp time known, and the value which we use, we need the payload and then the clone method of that payload. So that compiles and I'm not gonna say it works, but it compiles. Okay, so now we don't have to do this. We don't have to like whatever return switch self and then whatever, all the possible things like this. Like this is a trade-off here. Here, so like this, like, and then you would get the action out, and then you would say action clone. Okay, actually that's not enough because you have to do action and then brush paint goes to that. So you have to do that for everyone, and every time you add a new thing you have to add it here as well. But now we don't have to do that because we have this weird thing here. Okay, so that's a bit of comp time magic, but it's not, I haven't tested it, so I don't know, I'm not sure if it works, but I just finished up fixing all the comp time errors. In theory, in my mind right now, it should work, but yeah. Alright. Now let's continue here fixing these errors. Yeah, so we have this clone. So what's the issue here? Oh yeah, so we fixed that, yeah. And what's going on here? Cannot assign to a constant. What? Oh, this needs to be mutable. Expected error unit type. Okay, so deserialize does not have an error type. So let's just double check this. Wait, no, it's in this. No, it does have an error type. So the wait. So this guy needs to be an error type there. And what's this? Runtime. Oh yeah. Now we're running into these things. So great. Wait, but shouldn't this be comp time known? I'm pretty sure, right? And then what's the issue? I'm pretty sure. All of this is comp time, so I'm not sure why it complains here. Runtime non argument. Huh. I mean, I guess I can do this. I can do extension equals to I think comp time break, and then break. Like that. Right, that's the extension. Oh, then we need a tag. Right. So we need a tag and I mean, I think you can do this as well. Right? I think. Yeah. Whoops. I mean, that would be awesome. Okay. Yeah, okay, so we have a bunch of catch and reachable we need to take care of here. Non-persistent data.load. Expected 0. Right, so let's go to non-persistent. So all these actually, was it? This one is, yeah, it's non-persistent upload. There. And then scene. Yeah. There we go. All right. Whoa. Okay. I'm not convinced that's the only errors here. Document has conflicting types. What? I'm not sure if I have seen that error before actually. I hope this is not a sign that the things that I've done is not supposed to be done. I mean, that's always the feeling that you have. Oh, is it this one? Or wait. Okay, let's go up here. Document, it's supposed to be, wait, what? This should return this. Right, is this the same issue that with the action thing? It's like we're not actually, we should return a document content, right? That's what we should return. But then document is, there's no field like document, so we have to do the same thing, I think, here as the thing. So I think, yeah, we have to do slot data. No, where is intro? Document type. Wait, isn't? So will this work? Because it's not the value, it's the tag itself. Can we? What do we get out here? I'm not sure what we actually get out here. Well, actually, let's try union init, and this is document content. This is tag name of document 12b, I guess. But just try it and see. Init expression is this. Yeah. What is this now? Expected type. Found a whole bunch of stuff. Document type. Right, so we go to scene, document. Oh, I see, I see. I see the issue. Right, so here we actually do document. There we go. Well, I say there we go, but still gonna be some issues, I think. Okay, okay. Now we say expected document generic, blah, 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 found type info. What? Error unions. Oh. Oh, okay, so we'll do try. Will this work? Okay, so it found the pointer instead. Okay, so let's not do a pointer. No, document generic. Let's not do a pointer. Wait, no, this needs to be a pointer. But this does not need to be a pointer. There we go. All right. Now, save, disappear, please. Yes, it compiles. Okay, it's gonna be a nightmare to hunt down some weird bugs from this, but yeah, we'll see. Maybe it might all just crash and burn and I have to redo a bunch of stuff. We'll see. That's part of the fun. Okay. Just checking some stuff here. Right. Oh, more errors. Well, yeah, okay. Here's the error. So member function expected 1. Yeah, this needs an allocator, I believe. Hopefully that's the only issue. No. Expected this, found that. Okay. Let's not do a pointer. I'm sort of shifting my like usage of pointers. No. Instead of trying to figure out, okay, where can I get away with only copying values and stuff. So, and we don't need, do we need to initialize? Yeah, probably. Let's actually just do this. And then we copy the frames and the name. Sure. It's interesting. It's going to be interesting to see if we have any leaks after this. Okay. What's going on over here? Frames. Right, so this is unmanaged now. Let's do capacity. Okay. Oh yeah, cache unreachable. Oops. Expected found array list. Oh. Items. Error union is ignored. Yes, it is. Found string blah blah blah. Wait. No. Okay, so here we actually need to do something. So I guess we could just use init. So this would be, maybe we could just do type of clone init. Init wait, what? Oh no, init, and then allocator, and this is slice like this. Yeah. Oh, why is it going in insert? Okay. What's going on? Expected this from that. Okay. And the initialize expects that, so let's do mutable there. Expected. Okay, so this one does not have. Well, it does have error. What? Found. What? This can return an error, so we're catching it and returning the error back. This can also return an error, so I'm not sure what the issue is. Is it because we're returning directly? And then return documents? Is that better? No? Is this still an error? Is it double error? What? I don't understand. Catch. So we're catching it. Yeah, it says down there it's a document. Right? Is this, does this not work? I don't understand. Oh, I'm stupid. Okay. We want to return an editor, not a document. Okay. Right. That makes sense. Okay. So let's return an editor. And we can do init. Well, I mean, let's just do document type is document type and document is document. There we go. Okay. and you need to be mutable. Over here, also mutable. You are the wrong type, so we have to fix you. We're gonna have a bunch of these. You're also the wrong type. You are constant, so I think. Wait. Will that work? Yes. Same thing here. Inline else cannot enumerate. Right. Cannot enumerate. Oh, okay. So I need to do that. But then this is the same issue here. Oops. Can we do that? Okay, so now can we do this? I wouldn't think so, because then you would maybe have copied that, and that would be not mutable in the same way. Okay. Nice. Whatever else do we have? Classic thing here. Oh, this one. Wait. What's the issue? But this one is. Oh, I need to save here. There we go. Okay, let's always save first and see if it disappears. No. So clear and free. Is it this? Yes. Yes. Okay, now we're getting into some weird stuff. This one needs to be to Z. Okay, so now we have some weird things going on here. Access union field pointer while field struct is active. So where is this coming from? It's like it doesn't say. Coercion from enum document content union tag type to union document content must initialize scene document field scene. So it's trying to coerce the tag type. So that's the payload, right? Or no, that's the tag type, yeah. The tag type to from enum. Type info tag type to union document content. Okay, I'm just trying to figure out where this happens. It feels like we're trying to get the tag type from document content. So is this happening here? Is it this one? Is it... Wait, where is it happening? Tags? Where are we? Here? Okay, so it can't do that. Given an enum or error set type. But this is an enum. It's a tagged enum. So what's the issue? I guess it has to be an enum. It cannot be a tagged enum. Right. Okay. Well, that answers that. So we can't use this here. Okay. 1 second, getting a call. Alright, have to leave now, but let's see if I can just figure this out first. Just a quick look since we're deep in the weeds of this. So yeah, I think instead you wanna do fields. Fields, and you get a field, and well, it's not inline then. Get file extension. Wait, let's see. So field and if. Wait, we want to do. I think we want to do the same thing. Wait, get file extension. Tag. Is that gonna be the same thing? I don't think so. This is sometimes a bit confusing here. The tag is different. The tag is like you can't do tags. Okay, figure this out. I have to go now. So my brain is not working anyway for this, but we are very close to getting something that's at least running, I think. Well, at least compiling, I should say. And once it compiles, it might crash a bunch of times and I have to fix a bunch of things. But we have made a lot of progress, I think, from this, and it might all just be for nothing, but we'll see. At least we're approaching the kind of structure of the editor that I was thinking of first, and we also have the implementation of the whole animation editor to go, but I think I'm gonna. It's a bit different from the game development part of this, but it's gonna be more tool focused now because we have these goals set up, and yeah, I think I want to do this so that we can have a better platform to stand on in the future with the editor. But yeah, that's gonna be it for this time. So thanks for anyone tuning in, watching here. Hope you have a nice day, and I'll see you next time. Bye bye.